reinforcement learning. In the reinforcement learning, this Bellman-Fold algorithm is very, very popular. Still people are using this reinforcement learning. One more thing, for the object detection algorithm, we'll use convolution neural network. I will talk about this convolution neural network. And for the, whereas the decision making algorithm, there are hundreds of algorithms are there in the machine learning. Therefore, most of the time we'll use a decision trees, support vector machines, and deep reinforcement learning. This machine learning we are using hi-fi words and all that, it is basically most of the time probability and statistics. If a person is good in statistics and probability, he can easily understand what is this your machine learning algorithm. And databases are required. And here, if you want to have more data is required. That's why, as I use this one, when you're using this artificial intelligence, that is any technique that enables computer to mimic human behavior. That is all the things, what I mentioned, neural network, fuzzy logic, okay? Neural network will mimic our brain works, mimic the brain. Fuzzy logic, our mind, mainly brain is different, the mind is different, okay? Like that machine learning, ability to learn without explicitly being programmed, okay? That is the, I will talk about. Here the word is that ability to learn without explicitly being programmed. Then how it works? Then deep learning extracts patterns from data using neural network. Therefore, image extraction like that. Now in this way, we see the machine learning, what it is doing is that, suppose a computer that is programming, I want to solve a set of non-linear algebraic equations. I use generally Gauss method, Gauss-Seidel method, Newton-Raphson method. Suppose this is a software. Then what you will do, a data is required and corresponding program. I want to use Newton-Raphson, I should write a program for the Newton-Raphson. Corresponding data I should provide. I will get the output. This is a traditional programming, what I do. Whereas in case of machine learning, we are having this data, output is optional actually, okay? Based upon the data, suppose you are having in the machine learning, linear regression is there. Then data is sufficient. Based upon the data, suppose if want, I will get the program. Output is the program is shown. Program means what is that? It will not give the coding like in C or C++ or Java, it will not give the program, not that program. What it gives is that because here data, program, output is there, only by I'm playing with these three, that's why I indicated input is the data and output, and output of this for machine learning is the program. This program is nothing but model. When you are having this data, how you will model? X and Y is there. Regression. What is the relationship between X and Y? Therefore, in this one, I can model as a linear model. That is Y equal to mx plus c. M is the slope, c is the intercept. I can model as a non-linear. I can model based upon the problem, logistic function for the classification problem, etc. Then output is a program. Output is the program is nothing but a model. For example, if I will give an example, that is most of the time during last year elections, in TVs they will say they will do X party, Y party, Z party is there. They will say X party may win, Y party may win, like that. Then they will say that by using some artificial intelligence they might use. The artificial intelligence is nothing but they will use machine learning algorithm. They will have the interaction with 18 years to 25 years. They will collect the data. From 26 to 40. Once again 41 to 60, 50, something like that. Their way of thinking is different because the age group way of thinking is different. They will collect the data and they will process, they will form the model. Therefore, when model is y equal to mx plus c, already my m is fixed and c is fixed and x is input is the variable. Y is the output. Therefore, the m is fixed, slope is fixed as well as the intercept is fixed. If you give the input x, any value, there we get the output. Based upon this one, when model is predicted, then we can get the output. And one more thing also you might have seen in the newspaper several times in this pandemic, that is IIT Hyderabad, Professor Vidyasagar as well as from IIT Kanpur professors, they have developed for this pandemic, when you will get peak corona at that time. Recently also they predicted June ending or July ending, once again we may touch. Okay. Therefore, based upon the models, we can predict what happens. But most of the time, in this machine learning, people will use in industries very well. Because TCS, Tata Consultancy Services is there. Or Tata Motors is there, for example. The last 3 years data they are having. They want to predict next 3 years whether the industry will go into profits or loss. So everything is, the output is a program, it is a model. Model can be linear model or non-linear model based upon the data. Therefore, in this, the preamble for this artificial intelligence, because if you want to go for the autonomous vehicle, we require data is required and some intelligent algorithms are required. Therefore, the man has learned much from studies of natural systems, using what has been learned to develop new algorithmic models to solve complex problems. As of today, what we are doing is that, suppose as I mentioned, when you are using neural network, what you are mimicking the brain. Fuzzy logic, mind. Most evolutionary algorithms we are talking. In the evolutionary algorithm, what we are doing, we are using PSO algorithm, we are talking about ABC, artificial bee colony. PSO, what we are mimicking, how the birds are flying, optimum way. Artificial ABC, artificial bee colony, how the bees are collecting. Ant colony, everything we are mimicking from the biology. These ants are etc. And most of the time, the evolutionary algorithm, if you see, they are searching for the food. You see for the bees, or you can see the ants, everything for the food only, or you can any other algorithm. They will talk about only food, searching for the optimum way how to search the food. That is why most of the time, this evolutionary algorithm we will use for the optimization algorithms. Therefore, this AI is a machine emulation of human thinking process. That is why this how we are able to think in the fuzzy logic. What you will do is that the brain, mind, brain is different, mind is different. Brain you can able to see, mind can be able to see, mind, human thinking process. You may be sitting in the class, you will be thinking somewhere. Therefore, there is a human thinking process, that is the how we are mimicking the mind in case of fuzzy logic. The mind means what happens, in algorithm will be there for the mind. Most of the time, if you want to solve the brain, some algorithms will be there. I can convert Gauss-Seidel method into a neural network, okay, like back propagation algorithm or some other thing. But whereas in case of the mind, everything is based on the word. For example, I will give one more thing. A student has got 2 jobs. One is in TCS, another is the Infosys. How to select these 2 jobs? Suppose if you don't, it doesn't have any knowledge, what is the prospects and all that. Then what he will do, he will go to a person and he will collect the data, how the prospects and what, like that. He will go to another person, Infosys is working, he will collect the data. And when he got what tentatively he will know, what TCS, what my prospect, Infosys, what are my prospects. Therefore, how will come to join TCS or Infosys? Any algorithm is there? Daily will think that TCS is better or Infosys is better. Finally, it will come to, let us say, I may join in TCS. Therefore, it is human experience. Just in our villages, okay, in dispute is there between X and Y, what village it will do? It will listen A, X and Y also, what is it? Then after hearing both X and Y, it will come to a decision, yes, X is right or Y is right. Based on this, that is what we are mimicking in this fuzzy logic. Decision making, what we call. Therefore, in this one, in this neural network, the role model for the ANN is the brain, whereas the role model for the fuzzy logic is the mind. And one more thing, as I mentioned, evolution computing, as I discussed, that is everything based upon the ants, birds, etc. and all that. Therefore, if you see this second point, evolutionary computing began by lifting ideas from biological evolution theory into computer science and continues to look new biological research findings for inspiration. Evolution, what is evolution? Evolution means improvement. Okay, in optimization problem, I want to minimize the problem or maximize the problem, anything based upon the requirement. What is that? Vendors, what is the objective? You want to maximize the profits. So losses point of view, losses we want to minimize. Therefore, the optimization problem, we can make use for the optimum means, it can be minimum or maximum based upon the problem. And evolution is an optimization process where aim is to improve the ability of individuals to survive. Who is not able to, if you see the first point, evolutionary computing mimic Darwinian theory of survival of the fittest and principle of nature to make such process. Who is fit, he will survive. Who is unfit, he will out. Therefore, evolutionary computing is the emulation of the process of natural selection in such process, because any optimization techniques are such process only. Okay, as I mentioned, this collective behavior emerges from group of social insects such as birds, ants, bees, bacterial foraging, etc. And what is intelligence? Most of the time, we we will talk about AI, artificial intelligence. When talking about artificial intelligence, we will have some natural intelligence also. What is the natural intelligence? Our brain is the natural intelligence. Then in this one, how we will get, most of the time you see, if you take a class is there, some student is highly intelligent. Okay, what is the intelligent? Wisdom and knowledge both are same or both are different? Wisdom and knowledge both are different. Knowledge is that if after reading something I can get a knowledge, but wisdom, by reading anything you will get wisdom. Huh? Any one of you? Wisdom is nothing. What I will say, it is a common sense. Okay, based upon this one, this wisdom and common sense, there is one story you may be knowing, that is a cap seller story. A person is selling the caps, okay, or summer, May, let us say, and he's selling, start morning 8 o'clock he started, and 1 o'clock lunch time, he took the shelter under the tree, and he had his lunch. After lunch he slept. The cap seller also wearing the caps, and all several caps are there. On the tree, monkeys are there. The monkeys are also watching that cap seller. When he slept, all the monkeys came, they took all the caps, and they wear that, and this on the tree over there. After 1 hour, the cap seller woke up, caps are missing. When he seen on the tree, all the monkeys are wearing the cap. Then he got, that is, he also wearing the caps, he kept his cap on the ground, all the monkeys are watching, all the monkeys came, they also kept all the caps, like that in the tree. After going to his house, he informed his son, today this happened, okay, that is all the monkeys took cap, I kept my cap on the ground, all the monkeys also kept like that. That what father is saying to his son is the knowledge and wisdom. It's only knowledge, what happened, that incident. After some 1 week, he had some other work, okay, he sent his son to sell the caps. Therefore, he also started morning 8 o'clock, and 1 o'clock under the same tree has some shelter, and after lunch he has slept. As usual, monkeys are there, they took all the caps. When he woke up, caps are missing, then he recollected. His father told, when monkeys will take the cap which you are wearing, you keep on the floor, all the monkeys also will keep on the floor. Therefore, he recollected and kept his cap on the floor. Then one monkey, this time what happened is that, one monkey came, took that cap also. That is here, what I want to say is that the wisdom is different as well as the knowledge is different. There are these all knowledge-based systems. We can also neural network, fuzzy logic, these are all some, we can also knowledge-based system, not wisdom-based, okay? Just they will store the data. Therefore, in this intelligence point of view, how will you get intelligence? Because most of the time, if you see some people will be highly intelligent, medium, average and all that. The intelligent, what literature says, there is a relationship between adaptability and intelligence. One thing is that what people will say, some people will, while traveling they will not get sleep. They will go to a new place, they will not get sleep. Some people will be there, any place, happily they can sleep. Any place, happily they can eat whatever it is there. But more adaptive means that fellow is more intelligent. And one more thing is the intelligence will come, interactions. Suppose a class is there, in the class 60 members are there. The CR will interact all 60 members. That is, his knowledge is more. Suppose a student is interacting only 3 groups, 3 students become 1 group. Then what happens is their knowledge is limited to only these 3. That is, more information means more knowledge. More knowledge means more intelligence. That is what literature says. Therefore, intelligence arises from interactions among individuals. And most of the time, because just I will talk one or 2 things in this one. The capability, because we are to start this machine learning, even deep learning in particular, convolutional neural network, one of the algorithm of the neural network is the must, because that is also part of the convolutional neural network. Because of this one I will talk about, as on today, the general neural networks, what we will call shallow neural networks, because when we are addressing deep learning, okay, is a neural network, we will call shallow neural network. As I mentioned in the neural network, we are mimicking the brain. When you want to mimic, we should have a role model. So most of the time, what I will give an example is that after completing my BTech, MTech or PhD, I want to become a teacher, professor, whatever it may be. Then in the first class, how to teach? Assuming there is no formal training and how to teach. Good old days, there is no training at all. First class, we are selected means you have to go and teach. How to teach? Then what we will do? From LKG to my MTech or PhD, several teachers I might have come across. Out of, it may be nearly 100 or more than 100, who is the best? Still, we can recollect the name of the 5th class where start with mathematics. 10th class where start mathematics. Because why? Something is different. All the teachers I cannot remember. Few, okay, at least 3, 4 teachers still I can remember in my school or intermediate or so. Because some change is there. Their way of teaching, some motivation, whatever it may be. Therefore, similarly, if you want to take the brain as a role model, we should do some wonderful things. Then only we will mimic. Otherwise, there is no need to mimic. Therefore, in this one, if you see one of the things, some of the, for example, a pattern recognition. Most of the time we are using our biometric and all that. What is that? AI we are using everywhere. We are using AI in Alexa also. And biometric machines, which is our impression. Therefore, this, for example, this pattern recognition, to give simple example, let us say I am studying when 5th class. My friend was there. His name is Rama. And after, he is my close friend. And he used to sit beside me entire the 5th class. After his father was transferred, he left. After that, I completed BTech. I went to Bangalore. I seen a person like Rama. Because when you are having some interest, it will store in the pixels of the brain. When it doesn't have an interest, we will not take, our brain will not retain. Most of the time, I will come back to this point. We will purchase 100 rupees ticket or 200 rupees ticket as on today to watch a movie. After coming out to the theater, we will get headache sometimes. Why will we get headache? There is mismatch. I expected the movie will like this, like this, like this. But I expected something, the movie something, I will get headache. And most of the time, novels are there. Novels I will read, most of the time we read within 2 days, 3 days, while eating, without sleeping also I will read novel. Interesting. But a new subject is there, textbook is there. After reading 10 minutes, I will get headache, I will go for a cup of tea. Everything based upon our interest, and there is mismatch is there, we will get headache. Is it not? Some unknown information is there, some which is bothering us, we will get headache. What is this nonsense and all that? Is it not? Therefore, in this one, in the pattern recognition, come back to this point, I seen my friend, okay, close friend, 5th class at Bangalore. It's because a lot of noise, the height is changed, weight is changed, everything. But still, it's some features I've stored in the brain just by seeing it looks like Rama. I will go and ask, what is your name? He says, yes, my name is Rama. But several Ramas will be there. Then I will ask, which school you have studied? He says, so-and-so school. Oh, then they hear what I want to say this episode. There is only 1 year we are close friends, and it is stored because of the closeness. I cannot recognize all the students in that 5th class. Only by Rama only is a very close friend. When you are having interest, it will store the information in the brain. Most of the time students will say that I am unable to recollect and all that. Unable to recollect, why? We are not interested. Most of the time in our houses also, mother or father will say, well, coming from the college, you bring this one. Everybody will forget. Why will forget? It doesn't have any interest. When interest is there, definitely it will. Therefore, here, the pattern recognition problem is that what I'm saying, even though only 1 year they are close friends, after that there is no interaction at all. Still they can be able to, yes, he is Rama. Therefore, here, when you want to do any work fast and accurate, then this machine learning algorithms will do vital. Accurate means large data is required. Less data, it will not accurate. Error will be there, most of the error. And one more thing, this filter, brain also will have a filter point of view. How it is vacuum filter? Most of the time people will use in our in power systems, people will use as well EC, image processing and all that people will use. The filter is nothing but, once again, a simple example. I want to go to Delhi from Secunderabad railway station, because as you will know, Secunderabad, Delhi, the railway stations are very busy. Daytime, nighttime, crowded. Then my train is night at about 12 o'clock. Therefore, I reach railway station by 11:30, and I want to stay in Delhi some 1 week, 10 days. Entire day I worked very hard and all that. And somewhere, at the time my body wants some rest. Therefore, I will see some seats somewhere on the platform. After sitting, lot of noise will be there. Vendor is shouting, announcements will be there, and train noise, etc. and all that. In spite of noise, my body wants some rest. After sitting for a while, without our notice, we can happily sleep 5 to 10 minutes. Then what my brain is doing? It is filtering all the noise. Same noise is there in my house, I cannot. I will ask, control is there. Don't speak, I want to sleep, something like that. But there is no control. That's why brain is doing wonderful things. For a while, I can sleep. That is why most of the time these features we are using some algorithms for the filtering, processing in the state estimation, as I mentioned, as well as image processing in EC and all that. Okay. And anyhow, associative memory will use in computer science people several times. You associate the name itself. That is, if you know X, I can recollect Y. If you know like that, that is, I will come to my office. I will do certain work in my. Okay. I want to put X, Y, Z. After coming back, to open the door, my key is missing. Then what will do associative memory? I met X, I will go and ask, any key is there? He says, no, I will go to Y. Like that, we will do. And one more thing also you might have seen in good old Telugu movies, okay? Old movies. Now, hero or heroine, they will lose they cannot recognize other. They will go to change of place. Or seeing something, they will recollect everything, okay? Association. Therefore, and one more thing, scanner and brain, both are same or both are different? Scanner and brain. Scanner will scan, I will keep my text, I will get the replica of that I will get, I will keep my photograph, the scanner will give replica of my photograph will give. The brain also doing same thing. Then both are same or both are different? Scanner will do temporarily. But brain, if you are having some interest, it will store in the pickles of the brain, anytime we can retrieve. And one more thing, is it correct? Brain as a plastic organ, is it plastic? No one inside is not a plastic. Huh? But then why we are calling plastic is that we can mold the shape. That is, most of the time in the society we will see a person is very good. The newspaper after some time to come is very bad. A bad person is good. Huh? And one more thing also we will see, a student is average of 10th class. That fellow will become class topper in the +2. A student is of 10th class is a class topper in the school, but after +2 decreases efficiency. What is happening actually? How you will train? Is it not? Whatever the things are there, we can erase, we can rewrite, we program ourselves. Huh? That is the only thing is that mindset. When your mindset is there, we can do anything. Not coming? If you see the traditional programming as well as the knowledge-based programming, as I mentioned, to solve traditional means algorithmic approach, model-based. Therefore, suppose I should solve a set of equations or whatever it may be, we write the program. After writing the program, which is knowledge, is it possible to identify? We cannot. Everything looks a program only. Therefore, in the traditional programming, we cannot separate which is knowledge, which is the program. There is program and knowledge together in the traditional approach, algorithmic approach or model-based approach, what you call. Whereas in case of AI means we can call this data-driven approaches. This we can show separately, program is different, knowledge is different. In case of neural network, knowledge is stored in terms of bits. By the training is the process for that one, objectively we can see. Whereas knowledge is stored, show separately, and program is different. Both are interchangeable. This is the basis for the AI base. In this one to proceed, okay, this biological neuron is nothing to do but briefly, there are some of the words we borrowed from this biological one, that is what we call this dendrites, nucleus, soma, etc., which are there in this one. This model, to understand the neural network is very, very simple. But only thing is that we require most of the time what I will insist, hand calculations one should do. If we do some hand calculation, how we do proceeding, then we never forget in our lifetime. But most of the time what we will do is that students will do, okay, software is available, some MATLAB and all that, give input, we will get the output. What is happening? We don't know. That is why I will insist, we should do hand calculations. Okay, suppose simple model, there are several models are for the neuron, okay. To write a program, we require modeling. Modeling means, what is modeling? Anyone can tell? Modeling means equations. Without equations, I cannot write a program. Therefore, the biological is there, I cannot know equations. Therefore, to convert into equations, a simple model, most of the time people will use in any algorithm. Input is some x1, x2, xn, and this is the neuron, summation is there, linear, and my weights are there. Weights are nothing but small numbers. The connection, x1 is connected to this neuron, this circle what I shown. Weight is 0 means no connection at all. The weights can be positive as well as the negative. And net is the net input. What is the net input? It is nothing but x1 w1 plus x2 w2 plus dot xn wn. I will get the net. But if I will stop my output here, net itself, then what happens is that is the linear. Neuron is linear. When neuron is linear, then what happens? Most of the problems are non-linear. Problems are non-linear, we cannot attack. It cannot solve. Neural network cannot solve. Therefore, if you want to convert this linear neuron up to this which is there, I want to convert to non-linear. Then to convert into non-linear, where having a non-linear function is there, then I will get the output. Output is a function of net. Therefore, what is the non-linear function? In the non-linear function, the functions are like linear activation functions. Okay, input is the x, output is f of x. Okay, like the threshold functions, and we are having a non-linear functions like this. Sigmoidal function is very popular. Input is the x, output is f of x. What is the f? F is this 1 by 1 plus e to the power of minus 6. When you are using tan hyperbolic, input is the x, f of x, output is 1 minus e to the power of minus x by 1 plus e to the power of minus x here. Gaussian function, okay, mu and sigma, mean and sigma will be there. Output is the e to the power of x minus mu whole square by 2 sigma square. Therefore, here this input, okay, this input is this x1 w1 plus so and so given to this function. If you use sigmoidal function, let us say here, then what is the output I will get? 1 by 1 plus e to the power of minus 6. Okay, or net I will get. Input is the net, I will get 1 by 1 plus e to the power of minus net. Then this is only a simple neuron. But simple neuron cannot do anything. Simple neuron, as a network, it can do wonders. Okay, as a single neuron, it cannot do anything. And one more thing here, this apart from this nonlinear functions, as in today in the deep learning and all that, we are using one more function, Rayleigh function. What is the Rayleigh function? It is a rectified linear unit, and it is like this. It is also non-linear function. Okay. Therefore, in this one, if you see, Rayleigh rectified linear unit is a non-linear function, and Rayleigh is popular because it is simple and fast way to include a non-linearity in our artificial neurons. Because in the deep learning, if you use the sigmoidal functions as well as the tan hyperbolic, the time-consuming process. Therefore, in the most of the time, all the activation function we are using in the neural network, therefore, we will use in the deep learning in particular this Rayleigh function. And Rayleigh performs well and is often the first choice of activation function when building a network, a new network. Activation function or nonlinear functions, both are same. And there are several variations of the activation function. Our Rayleigh function is there. This is, if you see, a gallery of popular activation functions. Top row, okay. This is the left to right Rayleigh leaky, okay. Some here exactly on the negative. It is some leaky. Some angle is there. Therefore, leaky Rayleigh, shifted Rayleigh. Several variations are there in this one. In this one, the basis for this one neural network is two things. There are two things will be there. One is the one we require is the algorithm, that is the supervised or unsupervised or reinforcement learning. Based upon these learning methods, learning with heart of the neural network or deep learning, and based upon that we will go for the algorithm. Some algorithm will work based upon once again supervised learning. There are different there are learning laws, supervised learning, unsupervised learning, reinforcement learning. In the supervised learning, as I mentioned, pattern means data, input and corresponding desired output is required. And based upon the calculated output, I will get an error will carry the weights. Okay. Therefore, like this in this one, to proceed, to come back to this definition, a network is like this. A neural network is an input layer, hidden layer, output layer. Therefore, input layer based upon the problem. Output, how many nodes are there in the output layer based upon the problem. Suppose I want calculate efficiency of the transformer. Then what are the inputs I require? Output of the transformer, iron losses, copper losses. The three input nodes are required for the input layer. I want to calculate only efficiency, therefore only one output node is sufficient here. Now the question comes, how to select how many nodes are there in hidden layer? Here, if there are 3 are there, how to select? I can go for only one node, I can go for 100 nodes. There is no, as on today, exact mathematical formula, but what it says that hidden nodes should be approximately 1.5 times more than the input layer nodes. If 3 are there, 3 into 1.5, approximately. You can increase or decrease. But the hidden layer node should be slightly more than the input layer nodes. That's why when you use the word more, fuzzy word, then how much more? That's why the cap is 1.5 times approximately. And here the weights, we initialize the weights between input to here, here for example with respect to the feed forward neural network we'll call. This is the hidden layer, 3 nodes, here 2 nodes are there, 3 into 2, 6 weights are required. That is we'll call this 1, 2, this 1, 2, 3 are there, W11, W12, W13, W21, W22, W3, like that. The weight is a matrix between layer, input layer and hidden layer. Similarly, 3 into 2, 6 weights are required. Then we initialize the weights randomly between in the range plus and minus 0.5, plus or minus 0.25. Within that one, we will initialize the weights. Therefore, this is the same feed-forward neural network, input layer 1, layer 2, layer 3. And we will call recurrent recurrent neural networks or feedback. It is like in control system, we will use feed-forward and feedback. It is a feed-forward network. That is, it will go to input to the hidden to the output, feed-forward. Whereas in case of the feedback, okay, our recurrent neural network will call, output is fed back to the inputs once again. Okay, it is used some different business applications will go for the feed-forward or feedback. Okay. And one more thing in this one, in the supervised learning, as I mentioned, different algorithms are there, different learning methods are there, perceptron learning, delta learning, Wittroff learning, correlation learning, etc. For any unsupervised learning, supervised or unsupervised or anything, our basic objective is that we want to compute the change in the weight expression. Therefore, in this one, if you see, our initially the weights, we have to update the weights in the neural network. When you given the data, suppose if you see, for example, you've given some input, moving from, because hand calculation we should do, more clarity will come to hand. Initially the weights, some assuming some your transformer efficiency as the output, and output of the transformer, iron loss, copper loss you take as the input, and input to output, here some sigmoidal activation function you have to make use of, and from output to hidden layer to the output layer. Then what happens is that one of the algorithm which is popular is the back propagation algorithm. In the supervised learning, when input is there, corresponding desired outputs also will give here. Then what happens is that when you're given desired output, your efficiency is there. When you're moving forward from input to the hidden to the output, you will get a calculated output. Your calculated output and desired output, some mismatch initially. Error will be there. Based upon the error, we'll propagate backwards. We'll move from output to the hidden to the input. While moving backward, I should modify the weights. How to modify the weights? W equal W volt plus delta W. Then how will you get the delta W? From the learning law. What type of learning law you are using? Therefore, based on will move backward, will modify the weights. Okay. After once again I will give the input. I will move from input to the hidden to the output. Here desired outputs are there. I will get the error once again backward. In forward path, two passes are there. One is the forward pass, backward pass. After several iterations or several epochs, my network will be trained. How it's trained? Error goes on reduces, but goes on changing your weights, error reduces. When error reduces, what happens is that my network has learned. That is, where knowledge is stored? Knowledge is stored in terms of the weights which are connected between this input layer and hidden layer. Knowledge is stored. The knowledge is stored in terms of weights. When network has learned, we've got two phases will be there, training and testing. When training is over, then what we will do is testing. Testing what we will do, I will get new inputs, and there is no backward pass, only forward pass will be there. The input is given, I will get the output. This output should match whatever I calculated by using some formula. Then I can say that yes, my network is doing well. For example, one more example I will give. This any machine learning or deep learning or neural network, training and testing, two buzzwords. That is, it is like a kid is there. That is a kid LKG. When we admit in the school, what teacher will say? take the paper and pencil as on today. Kid don't know how to write A. Will take this hand, write A, this line, the first line, second line, third line, like that. Then after some, we will take his hand, we'll write this line, draw like that. If in the class 60 students are there, all the students may not have same IQ levels. Some students, they will learn within one day one alphabet. If the fellow is very, IQ levels are high. Some students, they will learn 2 days. After 2 days, they will learn one alphabet. Some students, 1 week or 10 days, one alphabet they will learn. Therefore, learning is always tedious process. It will take a longer time. The time we will not consider. Okay? Therefore, training and testing we also will call. Okay, training is nothing but learning. Training and learning both are same. Just like any organization, if you also join, like core companies, you have to learn, learning. Suppose BHEL. Then there will be some training they will do, how to work and all that. Some 6 months or 3 months, something like that. The network has learned means what happens is that your weights are stabilized. When the weights are stabilized, then what happens is that, then I'm testing. Here also, entire class, students have learned, after 2 months, they learned all the alphabet A to Z. Learning is over. The teacher want to conduct some test. Suppose if teacher asks, write alphabet A to Z, everyone can write, because A, associative memory. If I write A, I can write B. If I write B, I can write C. Like that all I can write. But teacher want to conduct some dictation. Write P, write Q, write Z, write M. Then students should know how P looks like, how D looks like, how B looks like. Therefore, this is like a testing what we will do. And one more thing also testing, most of the time, data. How much data is required? Suppose 1,000 is required. You use 2,000 data sets, more accurate results you will get. Suppose most of the time, suppose they generate 100 patterns, 100 data sets. Out of 100 data sets, most of the time, we should generate the data randomly, and out of that, 70% we should keep for the training, other 30% for the training. Therefore, same data we should not test. It is like, for example, I will give one more example. When I'm doing a problem in the class, okay, I will say that this problem is very, very important in the class. It may appear in the examination. Therefore, most of the time, what student will do is that they will memorize sometimes. But same problem, but numericals I will change. When 10 is there, I will make it 5. When 5 is there, I will make it 6, like that. I will do same problem 6 times. Students can able to do. In the exam, I will give same problem, but 6 times or 5 times which I done in the class, same data I will not give. I will give some other data. Testing. Then the students can able to do, because if I understood how 5 times you have done same problem with the 5 different data sets, in the exam, the data set is different. Data are different. Still, student can able to do. That is testing. Therefore, here, the training and testing will play a vital role, and based upon the problem, we will use feed forward and feedback neural network. And one more thing, just this unsupervised learning, as I mentioned, if you see in this one, unsupervised classification procedures are often based on some kind of clustering. Clustering means grouping. Clustering strategy which forms groups of similar patterns. Then most of the time, there are several algorithms for the clustering. Data looks like same, but I want to make different data, different groups. For example, before proceeding this unsupervised, in the class, if you see the first year, first day of the BTech, students will come different places. Let us assuming A don't know Y, A don't know B, B don't know C, and all different. When first day, class is over, one will go to north, one will go to south, and all that. After 10 days, if you observe, what happens is that in the class, all will form some groups. The 5 will become one group, 10 become one group, 3 become one group, and all that. How they made friends? First day they don't know. All are different. How they become friends? Because most of the time we will say to become the friends, we need not suppose friend qualities are 100 are there, assuming 100 qualities need not be same. One quality is sufficient to become a friend. Suppose a student has gone to library, some his classmate is reading. He is also interested in going to library. They will become friends. Suppose a student has gone to Daba or some hotel. If I have seen his friend there, they will become friends, because at least once in a week we can come to the hotel. Hotel friend, okay, friends are different. Huh? Therefore, clustering based upon the similarity. Therefore, we use Euclidean distance, several K-means clustering algorithms, several methods are there for the clustering. Okay. Therefore, this clustering technique is very useful for pattern classification problem. Therefore, most of the time, these unsupervised learning algorithms are used only for clustering or grouping. Okay. Okay, this is the updating the weights. Without updating the weights, there is no neural network or deep learning will not work. Therefore, this is very, very important. W equal W volt plus delta W. This is delta W change the weight expression you will get from the learning algorithms. Just like what I mentioned in this one, if you observe perceptron learning, delta learning, change the weight expression is eta into so and so, etc. The objective of learning is that the objective of any learning law is that it should eventually lead to a set of weights which will capture the pattern information in the training set data. In the training, what is happening is that every time I'm sending the data input and it is modifying the weights and come back. Several data sets, 1,000 data sets, 100 data sets and all that. At the end, my weights are stabilized. Knowledge is stored. One more with respect to training, I will give one more example to understand. Daily I'm watching a TV serial, 8:30. As you know, TV serials, they will continue up to 1 year also. Last 3 months I'm watching the TV, some serial, 8:30 daily. Every when serial 5 minutes or 10 minutes over, some advertisement is there. What is that? My Sony TV is the best. After some time, my LG washing machine is the best, like that. Suppose after some time, because 3 months, since last 3 months I'm observing every day, Sony TV is the best. One day in my house, let us say, a TV, I want to purchase new TV because some issues are there. I will go to a shop. Because already my brain is biased. Which is the best TV? Sony TV is the best. Therefore, I will go to a shop, it shows all TV. That is Panasonic TV, LG TV, several things. But I will ask, where is the Sony TV? He says that in my shop it is not available. Then what we will do? Already is biased, I will go to some other shop. After satisfying that performance of the Sony TV, I will purchase only Sony TV because already biased. Therefore, here, while training, okay, that is most of the time, in the house also, kids, we should not scold. You are useful, daily if you scold, it will become useful, useless, isn't it? If you say daily, useless fellow, you shout on him, and then what happens? Training. He also, kid also thinks that I'm useless, that's why my father or mother is saying that useless. That everything is based upon how you train. That is why I use the word in the beginning, we can reprogram. Brain is like a plastic organ, we can modify whatever you want. Good is there, we can improve still further. Bad is there, we can remove also. Okay, okay, just this back propagation algorithm, it is a feed-forward network what I shown, and it works very superficial. I'm talking this is. Initialize the weights between input to the hidden to the output, and initialize the iteration count I, okay, and read an input pattern P, and starting from the nodes, from first hidden layer node, compute that is net, okay, and output based upon the activation function. If you are using sigmoidal 1 by 1 plus e to the power of minus j, you will get the output. Output is a function of the net, and update the weights. While error is there, while moving from output to the hidden, I will modify the weights using the formulas. And once again, when error is small, you will stop. Present error and previous error is less than or equal to epsilon, then network has learned. Then I will give a new input to test whether my network is trained properly or not. That is how back propagation algorithm works. Now we come back. This is how the neural network will work. Come back to this machine learning. As I mentioned, this machine learning, neural network is part of the machine learning, but slight variation is there. In this machine learning is a form of AI that enables system to learn from data rather than through explicit programming. However, machine learning is not a simple process. As algorithm training data, it is then possible to produce more precise models based on the data. We'll get only precise models based upon the data. That is, before coming to this one, in this one if you see, in the machine learning, the most common type of machine learning is learn the mapping. That is y equal to f of x. Y is the output, x is the input. What is the f? F is the model. Therefore, y equal to f of x to make predicts of y for new x. This is called predictive modeling or predictive analytics, and the goal is to make the most accurate prediction possible. Therefore, in this one, in this one, the common principle that underlies all supervised machine learning algorithms for predicting modeling. Machine learning algorithms are described as learning a target function f. We want to learn this model f that best maps input variables x to and output variable y equal to f of x. In this all machine learning algorithms, we are modeling linear model or non-linear model. This function we are modeling based upon the data. Therefore, when this function is, as I mentioned, linear model y equal to mx plus c, m and x I can calculate, m and c's I can calculate from the formulas and all that based upon the data, and any x is given, I will get based on corresponding y will changes. Therefore, this is the general learning task where we would like to make predictions in the future y. Future, given a new examples of input variable x. We don't know what the function looks like, whether it is linear or non-linear, based upon the data we should decide. We don't know what the function f looks like or it forms. If we did, we would use it directly and we would not need to learn it from data using ML algorithm. Therefore, more data, more accuracy you will get. Therefore, in this one, in the analytics, most of the time, it is when you have data science or data analytics, we are using that word. Analytics is, there are three types of analytics is there. In the three types, one is the descriptive analytics. In this one, it describes the problem, that what to do, what do the data looks like, description. Predictive analytics, that is more based upon the statistical models. That is, in the predictive analytics or predictive modeling, what is going to happen with the data. That is a model y equal to mx plus c. Based upon the input x, then what is the output? Okay, I can predict, and as I mentioned, I can predict in the next few months, Tata Motors will go into profits or losses. Predictive analytics, prescriptive analytics, it is use some algorithm based upon the whatever I'm getting, what decisions can be made from the data. That is action to do something. Therefore, we'll use an algorithm, that optimization, simulation, etc. and all that. Therefore, the machine learning is the predictive analytics. Okay, all machine learning we are using second point only, that is predictive analytics. Okay, this is okay. In this machine learning, several algorithms are there. I'm giving the names: linear regression, logistic regression, linear discriminant analysis, classification and regression trees, Navy Bayes, K nearest neighbor, and learning vector quantization, support vector machine, bagging and random forest, and boost and ADA boost, etc. Most of the time we are using in the autonomous vehicles also some of the algorithms in this one. Now come back to one more algorithm, there is the deep neural networks. In the deep neural networks, once again we will also having feed forward deep neural networks and feedback, and as well as the recurrent. Okay, feedback or recurrent both are same. Okay, and some algorithms based upon the deep reinforcement algorithms, several types are there. The fundamental algorithm of the deep learning is the convolutional neural network. Okay, in this one several variations are there. In this one, I will talk some of the features of the deep learning. So whenever I want stuff, please inform me. In this one, in this data science, is the collection and curating of mass data of analysis, where AI is implementing the data in machine for understanding the data. There is the data science. When you're using data science, is the collection of skills such as statistical techniques, and AI, artificial intelligence, algorithmic techniques. In data science, when large data is in power system, state estimation is the large data, then we talk about statistical techniques. In AI, some algorithms, okay, just like what you have seen, back propagation algorithm, linear regression, non-linear regression, etc. And here, in the deep learning, we are having artificial neural networks. It is used for the pattern recognition. When talking about the deep, there is deep neural networks, several things. That is, one is the convolution neural network for image processing, etc. and all. Yes, And one more thing is the recursive neural network, that is speech recognition, and deep belief neural network, etc. Therefore, in this one, most of the time, this convolution neural network is feed-forward neural network, just like we have seen feed-forward and feedback, etc. Convolution neural network is a feed-forward neural network that is generally used to analyze visual images by processing data with a grid-like topology. That is input, most of the time, the CNN will image means it is a two-dimensional data is required. And it is used several applications. One is playing games, composing music, autonomous driving cars, building robots, medical diagnosis, etc. Several applications people are using this convolution neural network and some other networks. Okay. In this one, as in the neural network, shallow, whatever so far I discussed, shallow neural networks. In the deep learning, what is happening is that the structure is same, but number of layers are different. In this one, in the CNN, see the last point, CNN is composed of multiple building blocks such as convolution layers, Rayleigh layer, the rectified linear unit. Activation function will use Rayleigh function, and pooling layer and fully connected layer. This is the difference between the shallow neural network as well as the deep, this convolution neural network. In this one, you will have this input is the image, the two-dimensional data, and you will have the kernels or filters, what we will call convolution. Okay, the process how we will do, I will explain. And Rayleigh function is used to convert. A convolution process is a linear process. Convert into non-linear, we are using this activation function or non-linear function. Okay, this like several things will be there, and one more thing, max pooling, etc. Several functions. Then fully connected layer. Fully connected layer is nothing but the back propagation algorithm is used here. That's why I discussed so far this back propagation algorithm. In this one, this layers in CNN, output layer accepts the pixel of the image as input in the form of arrays. Two-dimensional layer will be there. It may be 5 by 5, 6 by 6, 10 by 10, whatever it may be. And hidden layer carry out feature extraction. Most of the time we'll use image feature extraction. There several images will be there in autonomous cars captured by the sensors as well as the cameras. Therefore, we will extract the image. Therefore, hidden layers carry out feature extraction from the image, performing certain calculations and manipulations. Therefore, some of the hidden layers, as I mentioned, convolution layer, Rayleigh, rectified linear unit, pooling layer, etc. And fully connected layer. Okay, just what is the kernel function I will talk. Okay. The convolution, suppose if you take images, it is a 6 by 6 image, and we require some filter, because to extract some of the features, a filter is required. It may be 2 by 2 or 3 by 3 or 4 by 4. Most of the time people will use filter as a 3 by 3 they will consider. And here they will place this filter on this, suppose 301.158.272 is there. This filter they will place on this one like this. This is 301.158.270, and this filter 10 minus 1, 10 minus 1 also. And you will calculate 3 into 1 plus 0 into 0 plus 1 into minus 1, 1 into 1 like that. Then output is minus 5. This is one convolution. That is entire thing. Suppose this is my image and filter I will use. This is here. After completing this one, I will use one stride, means here I will start from 0, 1, 2. This max I will take. This column I will remove. I will call that is a stride. Okay. I will keep here. I will get overall. It is convolved features are -5, -4, etc. and all that. Therefore, in this one, when we are having this, when based upon this, my input is n by n. The filter size is filter or kernel, what we will call f by f. My output is n minus f plus 1 into n minus f plus 1. N is it is a 6 by 6. Your filter is 3 by 3. N minus 6 minus 3. 6 minus 3. 3 plus 1, 4. 4 by 4 matrix I am getting. This is a convolution operation. Therefore, in this one, based upon the convolution, I want to make it is a convolution operation linear. I want to make it non-linear. We are using Rayleigh function. And the Rayleigh function is, as you have seen, that is, if your function we have seen that is negative, you will make it always zeros, and positive is there, it will take same value. That is a function of x equal to x. -3 means output is 0. F of 10 means output I will get 10 only. And to go further, here if you see this output I got, let us say 1, 14, minus 9, 4, etc. Where positive is there, after using this Rayleigh function, I will get one positive value written same as it is. But wherever negative is there, I made it 0. Like. This is some of the features of the Rayleigh function to convert what is that convolution plus Rayleigh. Rayleigh we are using to make it a non-linear. Okay. Okay, there is some derivative and all that. Okay, I will stop here. As time is 11:30, some other lecture is also there. Therefore, to stop, before stopping, if you are having any general questions based upon this one, you can ask. Because I only partially covered this deep learning, but general, those are working in this area, they can ask some questions.
Thank you, sir. Thank you for your elaborate lecture on deep learning and machine learning. Can you throw some light on the applications of these things in power systems?
Power systems, everywhere we can use, most of them. From the beginning, we can load flows itself.
Load flows.
Back propagation.
Are they are using in real time, sir?
Real time in the load dispatch center, still people are not using.
No, still.
Yeah. Okay. Load flows from the beginning.
Yeah.
Then we are doing in 92 onwards.
Yes, sir.
For load flows, as well as the security, as well as classification point of view. Let us say fault class, yes. LG fault, LL fault to classify several applications. State estimation.
Yes, sir.
Because my PhD thesis is based on state estimation.
Okay.
On this, instead of using WLS, if you use neural networks, different SM networks.
Okay.
Okay, I talked only RB, back propagation algorithm. There are several algorithms, RBF, radial basis function, and SOM, self-organizing map. Like based upon the problem, we should take the algorithm.
Yes, sir.
Yes.
And coming to these electric vehicles, which are highly distributed in loads, while conducting the system studies, how do you model these electric vehicles in system studies, sir?
Electric, I'm talking about not EV, I'm talking about AV.
Autonomous vehicles, otherwise. Yeah.
Therefore, in this one, because this is a part of the, when you're talking about autonomous vehicles, we require, without machine learning algorithms, we cannot.
How do you model these things in energy studies, sir? Like load flows or anything?
How
do you model while conducting these studies?
Studies means I cannot.
Load flow studies or stability studies?
Load flow studies, it is different. No? It is only for the planning studies and all that. It may be transmission or distribution system. Oh, suppose, load flow studies, how do you consider suppose you take a 3-bus system is there. In case of 3-bus system, let us say one bus is slack bus is required, another bus is the load bus, PV bus and all. Or for simplicity, you can consider 2 buses or load buses only.
Yes.
Then what is the requirement is that, if what is the data which is given in the problem, okay, only one solution only I can get. Is it not? But I want to generate hundreds of sets, 1,000 sets I want to generate. Then what we will do is that, suppose load bus is there, the loads, most of the time loads will change. Generations will almost constant. Loads will change. Suppose load bus, let us say, my real power is some 0.5, reactive power is 1.0, something like that. Then what we will do is that, this 0.5 is there, I will make it, suppose you want 100 data sets. Therefore, to generate the data randomly, what is the requirement? Minimum is required, maximum is required. Therefore, we will assume load is varied from 0.8 to some 1.2. Minimum is 0.8 and maximum is 1.2. Then this 0.5, I will multiply with 0.8, minimum I will get, multiply with 1.2. I will get minimum value, maximum value of the 0.5, of the real power of the load. Then based upon the minimum and maximum, I can generate a random number. How many you want? 100 you want or 2,000 you want? You can generate. So the reactive power also I will do. For all the loads only we will do, which is varying from 0.8 to 1.2. Then all are there. Suppose you have 100 data sets you have generated. 3-bus system or whatever it is. Then what we will do? 100 times you have to run the load flow. Then for 100 solutions you will get. Voltage magnitude, phase angle. Therefore, out of this one, You can select for the 70% the data for the, then what data you will give the input.
Yeah.
The desired output is same, your voltage varying phase angle each and every bus.
Yes.
V1, V2 will not give. V2, delta 2. V3, delta 3, like that. Input, most of the time people will give injections at each bus. Real power injection, react power injection, they will give. Somebody 3-bus system is there, I can give, okay, this is what we have done, I'm explaining. And 4 inputs will be there and 4 outputs will be there. P2, Q2 and P3, Q2. And here V2 delta 2, V3 delta 2. Hidden nodes we have to select.
Okay.
Then like that, we can train the network. And after training the network, your, as I mentioned, your weights are stabilized. Then after that, test it.
Yes.
That will be there. Whereas in case of classification, let us say, I want to classify fault analysis. Your input is something, your voltage is something, current is something. But corresponding to that input, what is the fault? I may have LG fault, LL fault, LLG fault, triple L fault, etc.
Yeah.
I cannot give 1, 2, 3, 4, I cannot give. What we will do is that in case of binary numbers or bipolar numbers, the 4 data sets, I will give first of all are -1, -1 I will give. Because 4 are there, I will give -1, -1, 4. Minus means -1. LG fault, let us say. Another one I will give +1, all -1, -1 I will give.
Okay.
Next, +1, +1, -1, -1. All plus like that. I can give the desired outputs. Instead of binary numbers, if you give bipolar, advantage is that binary if you give 0, 1 only.
Yes, sir.
If you train with respect to these binary numbers, what happens is that, suppose I will get some 0.5. But if I took that as a positive or negative, 0 or 1. Then we should, some limitation we should make. 0.5 and above only, 1, like that. But whereas if you take bipolar, plus and minus is there, based on minus sign, any minus sign is there, I will make it minus, 0. Is it now? Any plus is there, I will take that as the 1 like that. Then it is easy to consider bipolar for the classification. Then most of the time use this type of algorithm to generate the patterns. If you get the already real-time data, not an issue. But if you want to generate, 50% of the task is over.
Yeah.
Is it now? Then generating data is a crucial one.
Okay. Thank you, sir.
Okay, if there are no questions, I will stop. Before stopping, just 1 minute. There is one proverb or statement is there. If you are having a hammer, everything looks like a nail. If you are having a hammer, everything looks like a nail. We are getting in it looks like fuzzy, this word, is it, the statement? The meaning, if you say a real meaning, suppose our sons or daughters, they are coming from the hostel, what mother thinks that they are not taking proper food, she will prepare good food. Okay, 2-3 days happily they will eat and watch the TV and all that. 4th day, no work. So somewhere in the house, if you see the hammer, they will see any hammer is there on this wall. As in today, no wall is having nails and all that. Otherwise, they will see the table, any nail is coming out. Even though no nail, because in the hand, hammer is there, they just hammer it. Actually, with respect to this machine learning algorithms or AI techniques, generally what I will say is that the hammer is nothing but your tools. You may be knowing how to use neural network, how to use the machine learning algorithm, how to use etc. etc. There is a hammer. What is your nails problems? While reading, someone has done this one. Why can't I use this linear regression? Why can't I use deep learning? Something like this. They are the nails. Therefore, when you are having this hammer is there, you can nail it. These problems with that. Okay. Thank you very much once again, the authorities, for giving me this opportunity. Thank you very much.
Thank you, sir. It was an enlightening speech where you have focused on various approaches of data-driven, their integration, role of AI in autonomous vehicles, artificial neural networks, their analysis, central neural networks, and many more. Thank you, sir. Now, I request our beloved HOD, sir, Dr. Fanindra Babu Boba, to give the memento as a token of appreciation from GRIET. Now, I I request you all to go for high tea. The refreshments are arranged in room 4410. Please be back by 12 o'clock. The next speaker will be waiting for you. Thank you.
Welcome to an ever-evolving research and development center that has been consistently intensifying efforts in translating research to technology. ARCI, International Advanced Research Center for Powder Metallurgy and New Materials. An innovative center that has been working to quench India's thirst for high-performance materials and processes for niche markets since 1996. ARCI, an autonomous R&D center of the Department of Science and Technology, DST, Government of India. ARCI is primarily focused on developing nationally unique technologies through its application-oriented research and transferring them to Indian industry for commercialization. ARCI has been continuously evolving the formats by which it may engage with stakeholders from other R&D labs, academic institutions, and industrial organizations to develop technologies and innovative solutions suited.
Hyderabad-based ARCI, an autonomous institute under the Department of Science and Technology, is continuously working on different materials to develop high-quality lithium-ion battery.
Okay, bye-bye.
Hello.
Hello. Hello. Hello. Hello. Hello. హలో
ఇక్కడ పెడతాం సార్ ఎదురుగా కాదు ఇక్కడ పెట్టాలి వాళ్ళ మధ్యలో పెట్టేసేది
హలో
సైడ్ పెట్టాలి వాళ్ళు ఇప్పుడు తీసుకొచ్చి లోపల పెడతారు అలా
హలో హలో
వన్ స్పీకర్ సార్
హలో
ఎంత
Good afternoon to all the dignitaries, my teachers and friends. Once again, welcome you all to this wonderful event for this forenoon session, Second International Conference on Sustainable Energy and Future Electric Transportation, SeFeT2022, co-sponsored by IEEE Industrial Application Society and GRIET. Title sponsors, Atom, Visakha Industries, Industrial Partners, Interpol Technologies, Instasign Vanex Technologies. Now, I would like to invite the next speaker of this forenoon session, Dr. Srinivasan Anandan Sir, Scientist E, Center for Nanomaterials, International Advanced Research Center for Powder Metallurgy and New Materials, ARCI. Sir, I welcome you onto the dais. With the permission of Sir, I would like to give a brief bio of Sir. He completed his Doctor of Philosophy, Chemistry in Anna University, Chennai in the year 2006, awarded a prestigious JSPS Fellowship by Japan Society for Promotion of Science, Japan, awarded Young Scientist Award by the Material Research Society of Japan. He has more than 10 patents, 100 plus publications in various international and national journals and conferences. Coming to his off-field of interest, material development for energy storage technologies, lithium ion battery, supercapacitor and lithium ion capacitor. Development of UV and visible light drives photocatalysts for self-cleaning application. Development of large-scale process for the synthesis of nanomaterials. Now, I welcome Dr. Srinivasan Anandan Sir onto the stage to speak on the topic Development and Demonstration of Indigenous Energy Storage Materials, Lithium Ion Battery and Supercapacitor for Electric Vehicles Application. Warmest welcome, sir.
Yeah, thank you. Can you change? Hello, may I audible? Yeah. Thank you for your kind introduction. So, first of all, I would like to thank that great management, Professor Panindra, HOD, Electrical Department, Professor Ravindra, and the other organizing committee member for inviting me to deliver a lecture on this free conference session. So, recently I am seeing that your management continuously you are organizing such an electric vehicle related event. I think this is my fourth or fifth invited talk to the event which is related to the electric vehicle. I really appreciated your effort and continuously organize such an event so that the scientific community get awareness on that electric vehicle related that program and all. So with this I would like to start the presentation. So I think all of you might be aware of that global warming as well as that greenhouse emission and all. So there are a lot of issues because of that global warming, climate change, all the things are happening. So in order to achieve this target, that is 40% of vehicles should be electric vehicle by 2040, you should have the proper ecosystem. As of now, we don't have any battery technology, material technology as well as cell fabrication technology in India. So that is the reason government is funding many projects to develop our own material technology as well as cell fabrication technology. In ARCI, we have been working on both material development as well as that cell fabrication technology. So today my presentation highlights that development and demonstration of indigenous energy storage material which is suitable for lithium ion battery and then supercapacitor application. So I'd like to give brief outline of our institute. ARCI, it is a expansionist International Advanced Research Center for Powder Metallurgy and New Material, which comes under the Department of Science and Technology. So ARCI has in operation of 11 Center of Excellence. 9 centers are located in Hyderabad and 2 centers, Center for Automotive Energy Material, Fuel Cell, these are all located in Chennai. And the mandate of our ARCI is we work on the development of new material or novel process. Once we develop the material or process, subsequently we demonstrated at prototype or pilot scale level and transfer the technology to the Indian industry. So briefly our unique mandate is transforming laboratory research into technology and transfer to the industries. So I am working in Center for Nanomaterial. Our center mainly focus on that application oriented research which is relevant to Indian needs and condition. As shown in the chart, the area of the nanomaterial research addresses the material development for water purification, textiles, and then alternative energy material, nanocomposite, and then so material for alternative energy. So what we do each case, we targeted at the specific application based on the research work, what we carried out at the lab scale research. Important thing I want to highlight here, when you are doing research with relevance, always that impact it will be there. That's what we frequently interact with the industries, so that we will know that what are all the requirement, what kind of technology requirement. And also it is not only about that science, you should have the proper interdisciplinary team where that science, engineering, all that electrical background and all, it is required to develop that the technology. That's what we work, and then with this kind of multidisciplinary team, we develop that a lot of technologies. And this is the outline of my presentation. I will start explaining what are all the importance of that the energy storage system and the statistics about the global energy consumption. Then I will be talking about that the research and development activities of lithium ion battery, supercapacitor, and lithium ion capacitors. I think all of you are familiar with these slides. So this slide shows that the various sources which is available for that energy generation and statistics about that global energy consumption. As shown in the pie chart, so the major contribution energy coming from that coal, natural gas, and then oil. And if you can see that CO2 emission by burning all these fossil fuels, electricity generation and heating nearly contribute nearly 44% of CO2 emission. Then if you see that the transport sector is contributing nearly 16% of CO2 emission into that environment. In that 16%, nearly 45% coming from that transportation sector. So there are major issues when we are using these the fossil fuel or non-renewable sources for that energy generation. One is that depletion of fossil fuel. If you can see that the natural resources, it is available only for limited time. For example, oil available for 30 years, natural gas 60 years, and coal for only 200 years. So depletion of fossil fuel is the major issue. And then that increase in energy demand. As of now, the energy requirement is 13 to 15 terawatt per year. So in the 2050, it is expected the energy demand is about 30 terawatt. So you need that huge natural resources to meet that energy requirement. And then third one is CO2 emission. As per the statistics, we are the 4th largest producer of CO2, and nearly 1.34 million metric ton we are releasing into the environment. So these are all the major concern motivate us to move out from that IC based vehicle to that electric vehicle, and then energy generation from the renewable sources. You know that all that solar cells and then windmills, you can generate energy. And then once you generate the energy, you should have the proper energy storage devices. Lithium ion battery and then supercapacitor, these two devices are considered as that the promising energy storage devices. Each one, it is having that different working principle. Lithium ion battery, it store energy through electrochemical reduction, electrochemical redox reaction. It is basically involved that Faradic reaction, whereas supercapacitor, it store energy at the surface of the electrode. There is no chemical reaction involved in that the supercapacitor principle. The advantage here of lithium-ion battery, it store more energy, but the disadvantage is it takes long time for charging. Whereas in that supercapacitor, it store less energy, but within a minute it can get charging. That is the advantage, disadvantage of lithium-ion battery and then supercapacitor. First, I will be talking about lithium-ion battery. So basically, lithium-ion battery is a transducer which converts the chemical energy of its into electrical energy through electrochemical reaction. There are two batteries. One is primary battery, another one is secondary battery. Primary battery, it cannot be rechargeable, whereas secondary battery, it can be rechargeable. Whatever the battery which we are using in our mobile phone, laptop, camera, all it is rechargeable. So there are four components are important in the battery. One is the anode, cathode, electrolyte and separator. Anode usually carbon-based material like graphite, graphene used as a anode material. Cathode, all lithium-based material used as a cathode material. Electrolyte, the lithium salt LiPF6 and lithium perchlorate, which is dissolved in the carbonate solvent used as electrolyte. And then the polypropylene and cellulose, they are used as a separator, which is kept between the cathode and the anode to avoid the short circuit between that the electrode material. And this figure shows that the existing cathode and then anode material used in that battery. You may ask, what is the advantage of lithium-ion battery compared with the other existing secondary batteries? So you might be knowing that nickel cadmium, lead acid, nickel metal hydride, all these batteries are exist in the commercial market. What is the advantage of this lithium-ion battery over other secondary battery and all? If you can see the energy density, it means that how much energy it can store per kg of the weight. It can store 150 to 250 watt-hour per kg of material. Whereas if you can see that the lead acid battery, for example, it can store only 30 to 40 watt-hour per kg, because the voltage of this lithium-ion battery is high compared to other the secondary battery. Here you can go up to 2.5 to 4 volt, whereas other secondary battery, all the voltage is less than 2 volt. That is the reason the energy storage of these secondary battery is less compared to that lithium-ion battery. If you can see the other property like cycle life, high rate performance, it is moderate compared to the other secondary battery. So this slide shows that how that the lithium-ion battery evolved into the commercial market. So in 1976, Professor Whittingham first fabricated lithium-ion cell using lithium titanium sulfide as a cathode and then lithium foil as a anode material. The problem here is the voltage is less, only 2 volt, which is equal to the lead acid battery. Again, the energy density is less. In that 1980, Professor Goodenough, he replaced this lithium titanium sulfide with the lithium cobalt oxide, where the voltage it can go up to 4 volt. So whenever you are increasing the voltage, the energy density also it will be higher. And then by replacing this lithium titanium sulfide with this material, he increases the energy density, but still he uses that lithium foil as a anode material. So later Professor Yoshino, Japanese group, they have replaced that lithium foil, which is highly flammable in that ambient, and then with the graphite. So finally, lithium cobalt oxide as a cathode and then graphite as a anode. The Sony introduces the commercial lithium-ion battery in 1992. So after that, there are many material has been evolved, lithium iron phosphate and then NMC, NCA. There are a lot of other cathode material has come up. Similarly, the anode material also, silicon and tin-based anode, it has come up. So considering their recognition for that commercialization of the lithium-ion battery, they have been awarded Nobel Prize in chemistry in the year 2019. So next 2 slides, I will explain that how that lithium-ion battery work during charging and discharging. As I mentioned earlier, in any cell, there is a cathode and then anode material. Anode material usually graphite, and then cathode material, it is lithium-based compounds. And then in between you are keeping that separator to avoid the short circuit between the cathode and the anode, and then you are also keeping that electrolyte for that the lithium ion diffusion and all. So when you are charging, just you are connecting your mobile into that the power point, and then what happens? Whatever the lithium in that cathode side, it diffuses and intercalate into that anode side. Whatever the electron generated from this oxidation reaction, it is charging your device. So it is simply how the electron and lithium ions move from during charging and discharging from cathode to anode. And everyone, we want that fast charging. How we can make it fast charging? So there are two things you have seen that. One is that lithium ion, it is moving, and the other case electron is moving. You want to make it that lithium ion kinetics very fast, as well as the electron kinetics also should be fast. So how we can make it the lithium ion kinetics fast? You have to prepare that nano size cathode material, should be less than 100 nanometer, and then for that the electronic conduction, you should have the proper carbon coating, whether you have to do the carbon coating or graphene coating, so that the electronic transport of this electron which is generated during that oxidation reduction reaction, it will be faster, and then make your battery fast charging. During discharging, exactly reverse process it is happening, and then whatever the lithium intercalated, it goes back to the cathode material, and then whatever the electron coming out from that anode material, it used for charging, powering your devices. This is the simple mechanism where lithium ion diffusion from cathode to anode during charging, and reverse it is happening during discharging. So if you make it nano size and then suitable carbon coating, you can make it fast charging. So this, you know that all that the lithium ion battery extensively used in electronics and then electric vehicle application. So light electric vehicle starting from that the bike, and now fully explode for that electric vehicle application. So what is electric vehicles? The vehicle which is propelled by a motor and which is powered by a rechargeable battery pack. In electric vehicle, there are three important components. So you have that vehicle, and then there is a battery pack, lithium ion battery pack, and then you have the motor. So the power is provided by your lithium ion battery pack. So according to your battery pack size, it can store energy. Accordingly, it can give that the driving range. So the advantage I have listed out here. So 59 to 60% of the electrical energy coming from the battery can be used for the operation of the vehicle. Whereas in that the ICE vehicle, fuel-based vehicle, only 17 to 21% is only usable for that operation of that vehicle. And other important thing is there is no emission when you are using electric vehicle. Whereas in the case of fuel-based vehicle, lot of green gas emission and all it is happening. And then performance benefit, there is no that it is very smooth to operate, and normal whatever the electricity available in our house is suitable for charging that the battery. While talking about the advantage, there are several challenges which needs to be addressed for the successful commercialization of lithium ion battery. So the driving range now, that electric vehicle, at least whatever it is introduced in the India, it can go about 350 kilometer. Whereas in the fuel-based vehicle, it can go about 450 kilometer. So it depends on that the cathode chemistry. If you can keep on improving that the chemistry of material which are used in the cell, you can increase the driving range and all. So another thing is recharge time. Nearly it is taking 3 to 4 hours per charge. And then so there are many research keep going on that, how to do that fast charging. As I mentioned in my previous slide, you have to make that a nano-sized particle. Several strategies you have to adopt for make it fast charging. And every battery you can do that fast charging, but continuously you cannot do the fast charging. Only limited time you can do that fast charging. And then third one is battery cost. Nearly half of the cost is for electric vehicle is battery. So the problem is whatever that electric vehicle introduced in the Indian market, all with the imported lithium ion battery pack. So we don't have single company making that either material or cells. That is the reason we are spending huge money for that importing all that lithium ion battery pack. That is reflecting in the cost of that final electric vehicle. And then another thing is safety. So recently you must have heard about that lot of fire accident in the two-wheeler. So there are, as I mentioned, different components are there in the lithium ion cell. Particularly you have to play with the cathode chemistry to avoid all this accident. Whatever accident it happened in India, mostly they have used a nickel manganese cobalt oxide as a cathode material, which is stable only up to 30 degrees centigrade. Above 30 degrees centigrade, lot of heat generated within the battery, and then in the battery there are highly flammable liquid is there as a electrolyte, and it catches fire at some point of time, and a lot of exothermic reaction it is taking place, and then it is blasting. So without knowing that what kind of chemistry suitable for India, people they have purchased, and because of that all accident it happened. So you need to understand that what is the chemistry which is suitable for Indian climatic condition and all, and we prefer that LiFePO4, which is the safe cathode material to operate for our Indian climatic condition. So this slide shows that the various, the automobile, the company, they have introduced different that electric vehicle into the market. Among this company, Tesla is the #1 company who introduced lithium ion battery vehicle with that, the capacity of 85 kilowatt hour, and then driving range is about 425 kilometer. So this slide shows that our present EV market in India. So earlier Mahindra, they have introduced E2 plus a E-Verito. Recently you can see many electric vehicle, even in Hyderabad, Tata Nexon, which can go about 300 kilometer, and Tata Tigor, MG Hector, all they have introduced. And then Hyundai Hona, this is the highest one where you can go that single charge 450 kilometers and all. And also there are some hybrid cars is available, where there is small battery which can be used for start-stop application, and to make that fuel efficiency. So to improve the fuel efficiency, it also comes with some hybrid battery. And one of the biggest market in India is the two-wheeler market. And then you can see that many companies, they have been working on for that the two-wheeler electric vehicle. You might be knowing that Pure EV, Ola, Okinawa. Pure EV is our Hyderabad-based two-wheeler company. And then that Ola, Okinawa, all these three companies, the two-wheeler recently they catches fire. And then government asked them to work on that, what is the reason. And so I am also one of the member in that Bureau of Indian Standard, and we have been working on that, what is the chemistry which is suitable for our Indian climatic condition. And then we worked on that different cathode chemistry. Finally we have come up with 2 or 3 material which can be suitable for our Indian climatic condition and all. So recently that in Delhi, they have introduced that e-buses for public transportation. This bus you might have seen on our Hyderabad road. This bus is running from that airport to different part of the city, and then this Volactra company is working on this in tie-up with the Chinese company called BYD. Mainly they work on that lithium ion phosphate-based cathode chemistry. This slide is very important. This, it will give you the clear idea why that electric vehicle is better than that fuel-based vehicle. So Post India, they have put one statistics, considering average person drive 10,000 kilometers per year. So for example, when you are buying electric vehicle, the cost is nearly 8 lakhs. Battery cost, half of the cost is battery. For example, 3 lakhs, we have 3 lakhs out of 8 lakhs is for battery. If you are calculating the running cost, per charge you have to spend 50 rupees. With that charge you can run for 100 kilometers. For driving 10,000 kilometers you have to spend only 5,000 rupees in a year. On the other hand, if you can see the fuel-based vehicle, the cost is slightly lower, 5 lakh, and then considering if you are driving in the city, hardly you will get 10 kilometers per liter. Considering that the recent price of the petrol, 110 rupees per liter, so for driving 10,000 kilometers, considering the mileage of this and then the petrol cost of 1 ton per liter, you have to spend 1,10,000 rupees per year for driving 10,000 kilometer when you are driving with a fuel-based vehicle. Whereas in the battery vehicle, you are spending only 5,000 rupees. That is the huge advantage in the running cost wise. And other than this, so you are not emitting any green gas into the environment. That is the advantage. Other than that, you are getting all additional benefit. There is a tax exemption. So when you are buying electric vehicle, and GST is only 5%, whereas the fuel-based vehicle you have to pay 12%. And then registration fee and then road tax, always some exemption is there when you are buying that electric vehicle. And then government also given a lot of subsidy for this electric vehicle. When you are buying two-wheeler, you will be getting about 20,000 rupees the subsidy, and then for three-wheeler you will be getting 50,000, four-wheeler nearly 1,50,000 you will be getting subsidy from that government. So similarly for that hybrid e-buses also you will be getting that subsidy from that government. So why we are doing all this electric vehicle? So we can save up to $300 billion, which is equivalent to 20 lakh crore which we are spending for oil import from the Gulf country by using this electric vehicle, and avoid 1 gigaton of CO2 which we are emitting into the environment by 2030. These are all the advantage why we need to switch over from ICE vehicle to that electric vehicle. So next couple of slide I will be explaining that what kind of research we will be doing at ARCI. This slide is important. This is the roadmap how we have to move for that technology. Basic R&D, it is a very smooth passage. In the gram level, all we can do it. Nicely we can deliver that results and all. And then you have to go through that valley of death. Once you develop the material, you have to do that upscaling in that kg level or 100 kg level or tons level. And also if you are developing material, some kind of prototype you have to develop, and then you should have kind of that engineering background you need. And then if it is the process, you have to, whatever the process developed in the lab scale, it should be upscale. All these things you have to do. It is not possible only with the science background. You should have the engineering background to design the reactor or the furnaces and all. Once you establish everything, you can take that laboratory research into that the technology level. That's what ARCA we have been doing, and then we have come up with nearly 25 technologies so far, and then we have transferred to the industries. So in lithium-ion battery, two of our main objective is, one is to set up the pilot plant facility for the fabrication of cell, and another objective is development of the indigenous cathode and then anode material which is suitable for lithium-ion battery. So these are all that facility which we have set up at our Chennai center, starting from that mixing machine, the coating, calendering, slitting, winding. So starting from the material to cell, we have complete facility at our Chennai center. And as I mentioned earlier, lithium foil is highly flammable and very sensitive to moisture and oxygen. You have to handle in that humidity control room. We set up 30% RH room as well as that 0.5% RH room for that coating as well as cell fabrication. With our facility, we have fabricated many that cylindrical and then prismatic cells. So these are all the cells we have made using our the pilot plant facility. So where that capacity of the cell is ranging from 2 ampere to 50 ampere. The thing is, we have done all that cell fabrication, but all these cells we made with the imported lithium-ion battery material. So when you are keep getting that material, after some time, there is supply chain issues are there. They are not supplying. Even if you are insisting, they are increasing the price. There are a lot of issues are there when you are depend on someone for completely getting that material and all. And we understand the necessity for the development of indigenous material, and we work on that lithium-ion battery material technology. And as I mentioned earlier, there are several components involved in that lithium-ion battery. Among these components, 32% coming from only the cathode material, and 11% and this one anode, 11% coming from that anode material. Nearly more than 40% cost is coming from the cathode and the anode material. If you can develop the cheaper cathode and the anode material, you can also bring down that the cost of the final cell. That's what ARCI we are trying to develop, that the cost effective cathode material by large scale process and all. So this incident and all you might have seen. So recent time that Pure EV Okinawa and Ola two-wheeler catches fires, and government asked them to recall all that the particular batches of two-wheeler, and they have recalled from that customers. And what is the reason why it is catches fires in that two-wheeler? That is very important. So this is that the cell components, cathode, anode, separator and electrolyte. Separator is very 20 micron thickness separator used in that lithium ion cells. So what happened, there are 4 important the parameter which causing the fire. One is climatic condition. Our climate, even in the summer, it goes more than 50 degrees centigrade. So whatever the two-wheeler catches fire, the chemistry, whatever they used, it can withstand only for 30 degrees centigrade, that cathode, that called NMC, NCA cathode material. So the other thing is overcharging of battery. So every battery, it come up with a battery management system. So once it is charged, it will cut off the current which is feeding into the device. And during operation also, if the current or voltage, if it is overshooting, it will cut off that. So that power electronics, so since you are background in that electronics, the power electronics is very important for that lithium ion battery, which control that voltage and current during the charging and discharging. So currently we are purchasing all the commercial BMS from that, again from the foreign country. We don't know, that may be suitable for their climatic condition, it may not be suitable for our Indian climatic condition. One is the cathode chemistry, another one is the power electronics, and then the quality of the battery. So as I mentioned, no company is making the cells in India, completely depend on Korea and China. We don't know what is the quality of the cell, and we don't have any testing agency to qualify the cell, whether this can be used for two-wheeler or three-wheeler or four. So a lot of issues are there. So what happens is, when that temperature goes 50 degrees centigrade, so there is called that the SEA layer, solid electrolyte interface layer. During charging, discharging, it forms that. That is, it is contained that lithium carbonate. When the temperature goes more than 60 degree and all, first it decomposes, this solid electrolyte interface, and then once this start decomposing, slowly the temperature keep increasing, and then whatever the liquid electrolyte, it is all the carbonate solvent we are using, which is highly flammable. And then once that started decomposing, slowly the temperature it is increasing, and then separator, as I mentioned, it is only 20 micron thickness. It cannot withstand for this high temperature, and then both cathode and then it will be shorted. And then after that, once again 200 degrees centigrade, once this short happen means the temperature goes to 200 degrees centigrade, and then the HF, the strong acid, it will be generated, because in your electrolyte you have LiPF6, that fluorine it is there. When all this reaction it is happening, the strong acid it will be generated within the cells, and then that also it is kind of series of exothermic reaction it is happening in the cells. And then finally the oxygen released from that cathode material, it is kind of fuel for your fire. So when it is that explosion it is happening, the temperature it is estimated about 600 degrees centigrade. So these are all that the major reason why that the two-wheeler catches fire recently in India. So you have to be very careful about that cathode chemistry as well as the quality of the cell which you are using for making that cell. So these two cathode material extensively used in that all that batteries. One is LiFePO4, another one is NMC. So the energy density for this one is 180 watt-hour per kg, whereas this one is 250 watt-hour per kg. Obviously we will go for 250 watt-hour per kg, but the problem is this one it will be stable only up to 30 degrees centigrade, whereas this one it can stable up to 60 degrees centigrade. even with this battery, it can deliver the driving range of 80 kilometer. For two-wheeler, so are we using more than 80 kilometer in a day? So no one is using. 80 kilometer is more than sufficient, but in the safety aspect, this is the safest the chemistry one can use in that the lithium ion battery for two-wheeler in India. The other benefit is the cost wise it is only $80 per kilowatt hour, whereas this one $115 per kilowatt hour, and the cycle life also it will be higher, whereas this one it is only 1000. Other major thing is the cobalt. The cobalt only available in the African country, only Congo it is available, and then cost also very expensive and then toxic. Whereas this chemistry there is no cobalt free cathode chemistry involved in that. These are all the advantages of lithium iron phosphate. Considering this advantage, we started working on this development of material for electric vehicle application. So these are all that the advantage which I have pointed out in my previous slide. So very safe and secure technology, there is no toxicity like cobalt, and then the cycle life it will come 2000 cycle, and then the limitation here is low electronic and ionic conductivity. As I discussed in that the working principles of lithium ion battery, you should have the nano size as well as good conductive medium for the electron transport, as well as nano size particle for that to overcome that ionic conductivity. So what we have done, how we overcome that the low electronic as well as ionic conductivity. So initially we have adopted two-step process. One is first we have synthesized that LiFePO4. As it is LiFePO4, it is not electrochemically active. You need to have carbon coating to make it electrochemically active. So first this is the process called plain spray pyrolysis process. It is kind of completely wet chemical method, where lithium iron phosphorus precursors we have dissolved in that alcohol solution, and then it undergoes the pyrolysis, and the pyrolysis temperature is about 3000 degrees centigrade, and then we could able to synthesize that 1 kg per batch, 1 kg batch per hour we could able to synthesize. Then we have done that carbon coating in a second step process. So this is that two-step process, and we have evaluated the performance of our material, how much current it can deliver per gram. So our material it can able to deliver 141 milliampere per gram, and always whenever we develop the material, always we compare with the commercially available best material. So we compared our material performance with the material from TODA and another from UNTPL. Material performance is at par with that one commercial material, better than the other commercial material. So everything is fine, but the challenge is the practical adaptability, because it involved two-step process, and also when you are estimating the production cost, it is very expensive. Even though performance we are matching, but cost wise we are not matching with the commercial cost of the material. Then we developed that single step process. Both nano size particle as well as carbon coating in a single step we have developed, and we have adopted that high energy milling method, where we have put that lithium, iron, phosphorus, all three precursor and carbon precursor. All four we have taken without adding any solvent, and we have done that milling, and subsequently we have heated to get that material of carbon coated LiFePO4. So several optimization in the milling as well as heating, we have done that lot of optimization. The advantage is in situ carbon coating. Carbon coated nano size particle we could able to prepare in a single step, and ease of upscaling. There is no solvent involved in that, and then you can do that upscaling, and it is very cost effective, adaptable to large scale facility and industrial scale. So we have filed the Indian patent for this, and these are all the properties of our carbon coated LiFePO4. As I have mentioned, that particle size is less than 100 nanometer. All these particle, if you can see that embedded into the carbon network, you need that nano-size particle as well as uniform carbon coating, so that you can increase the lithium ion diffusion kinetics as well as electron transport. That's what we have done it, and it is pure phase of LiFePO4 we got it. So nano-size LFP particle with amorphous carbon coating has been successfully synthesized. It is not only gram level. So previous one we have done at 1 kg per batch level. Next we have tie up with that the private company who is having that large scale facility. So we have participated in the public private partnership mode. So where industry also they can participate in our research activity. In that mode we have used their large scale milling facility for making that 20 kg powder also we have tried, and then we proved that our material, whatever the process which developed worked at a higher large scale production level also. Initially we do the milling, these are all that milled material, and then milled material before heating we do that compaction. So why we are doing the compaction mean, as it is powder when you are keeping, so we apply that vacuum during the heating, so powder means it flies. If you are making compact there won't be any issue, that is the reason we do that compaction. And we heated in that pusher type furnace. Pusher type furnace, it is operate 24/7. So the production capacity is 100 kg per day. So that furnace also we used, and then we synthesized this material. Whatever we synthesized at 20 kg level, that material we have tested for that electrochemical performance validation, and we have validated at a different charge rate. 0.1 C means you are giving 10 hour for charging, 10 hour per discharge. When you are giving that slow charging, you will be getting that 150 milliampere hour per gram. So when you are charging at 5 C you are giving only 12 minutes for charging. So even at fast charging also we could able to get more than 100 milliampere hour per gram. And if you can see the cyclic stability, so nearly 95% retention of capacity we are getting after 850 cycles. And we have that two material, one is for high energy material where the carbon content is less, another one is high power content. High power material where the carbon content is 10 weight percentage. In both cases we obtain that good cyclic stability. Then this is that benchmark. We always compare with the commercial material. So the black one is ARCA material performance. This is the typical charge discharge profile of LiFePO4. If you can see the discharge capacity at 1 C is about 139 milliampere hour per gram. Whereas the commercial one, so the commercial one, it is equivalent to our the ARCA material, and we are better than other commercial material. But if you go for fast charging 5 C rate, our material could be able to deliver more than 110 milliampere hour per gram, whereas the commercial material, it shows that it delivers the less capacity. The reason is we prepared that nano-size particle with a good carbon coating and all. That is the reason we got that good capacity even at fast charging also. So finally, whatever the material which we developed, it is going to be used for making lithium ion cells. So we made that actual lithium ion cells using our Chennai facility, using that commercial graphite as a anode and using ARCA LFP as a cathode. This is the LFP graphite cell which we made. And also we compared the cell which is made from the commercial LFP. That would be the apt comparison. If you can see the discharge capacity, this is 1.51 ampere hour, the cell which is made from the ARCA LFP, slightly lower than that commercial LFP. But if you can see that the capacity retention even at a fast charging rate, our the cell made from ARCA LFP able to retain 92% of capacity, whereas the cell made from the commercial LFP, it can withstand only 77% of capacity only retention it is there. And when we are estimating, more than 14% higher capacity retention obtained for LFP cell which made from that indigenous our ARCA LFP, and the cycle life, everything it is better. So overall, we developed a process for making that in situ carbon coated LiFePO4 by single step process, and this process we demonstrated at a large scale and validated in lab scale as well as actual cells. Finally, this technology has been transferred to that private company last year in August 2021, and the Alox Minerals Private Limited, they have the technology receiver of this carbon coated LiFePO4, and we are the first technology, this is the first technology transfer happen in energy storage related program. And this company now they are trying to set up the big plant in Hyderabad with the production capacity of 1 ton per day. So it is not only transfer the technology, we also demonstrated our technology to that the technology receiver, and completely we have trained their people how to produce, and then we have transfer all that know-how document to them. That's what we have completely completed that the technology transfer. And another important thing is, so we have filed a patent as well as international patent also we have filed. And then when we have gone through some whatever the patent available related to LFP, they found that none of the Indian patent application is found to be infringent upon commercialization of ARC developed process in India. That is very important. So if it is overlap with the other process, immediately they will file the case, and then there are some commercial issues are there. So that also we made sure there is no overlap with the existing process available in India. So this is what about the cathode material. In the anode material, normally they are using graphite as a anode material. So we try to replace the graphite with the lithium titanate because the whole world is moving for fast charging now. As it is graphite, it cannot deliver that much high power when you are using graphite as a anode material, whereas lithium titanate, it can deliver high power because it is kind of zero strain material and also free from solid electrolyte interface formation and all. When you are using commercial graphite, there are SEA layer formation it takes place. This SEA layer formation, if it is keep growing, then there will be a short circuit, all the safety concern and all it is there. Whereas when you are using lithium titanate, there is no SEA layer formation, and during charging, discharging, there is no strain at all. So that is the reason they are trying to use this lithium titanate for fast charging lithium ion battery application. And these are all the advantages of the lithium titanate. So similar solid state process we have adopted for lithium titanate as well. So here, this is that high energy milling unit initially we used with the capacity of 2 kg per batch. And simply we have used that lithium precursor and then titanium precursor and then milled at some 500 RPM, and then subsequently we have heated, and this is kind of carbon coated lithium titanate. And if you can see the performance of the material which developed by ARCI, it is almost close to that commercial material. And these are all that morphology of the commercial as well as ARC LTO. It is 100 to 250 nanometer size particles, whereas the commercial LTO is about in the range of 100 to 150 nanometer. But when we are estimating the production cost, the commercial cost, it is coming 5,000 rupees per kg. Whereas when we are synthesizing using solid state process, we end up only 1,200 per kg. And this whole process we have filed in India, and 5 foreign countries also we have filed. The patent which filed in India, US, Chinese, Japan already granted. So here it is only 2 kg batch level. Then we started a large scale demonstration for the production of 20 kg level. Again we use this the high energy milling unit with the capacity of 25 kg, and this is our the milled LTO material with a 15 kg batch. And here I was saying that the fast charging, how it can deliver that the performance at fast charging. As I mentioned earlier, 1C means you are allowing battery for charging within 1 hour. 30C means you are giving only 2 minutes for charging. So you can see that even at 30C, our material can able to deliver the current of 84 milliampere hour per gram. Whereas the graphite and all, it cannot deliver, even it cannot go for 3C as well. But our material, LTO material, it can go up to do fast charging also, and it can able to deliver that much high performance. And the other thing is supply chain. Whatever the lithium raw material available in the market, whether it is suitable for our established process and all, we have sourced from 3 different sources, and we prepared LTO, and then when we check the performance, LTO derived from all 3 precursors almost giving the same performance. But the interesting thing is the material source from these 2 is per kg it is 1500, whereas this one is 11,410 rupees. By using this precursor, we could be able to reduce the production cost nearly 2,500 rupees per kg. And this material we have used for fabrication of pouch cell, and we made that all that cylindrical cells and all. And the performance 80% retention after 1000 cycles we could be able to achieve. And based on this, now we are going to announce this technology also soon. We will be transferring this anode technology to that the private industry. So this one 2020, so they have highlighted our LTO invention, and then whole video it was telecast in that Rajya Sabha TV. If time permits, I will show you that one. The other thing is the next part is I would like to maybe another 20 minutes. Time is fine, sir. 15 minutes, madam. I will try to finish it up. So so far I was talking about the material development for lithium ion battery, where it can store more energy, but the problem is it will take charging for long hours, 3 to 4 hours. So as I mentioned, lithium is available only South American country, Argentina, Bolivia, Chile, Brazil, China, Australia. Once you exhaust with this, lithium, what will you do? You have to look out for the alternative energy sources. Sodium ion battery, it is coming up, but it takes own time. So there is another energy storage devices called supercapacitor. There is no lithium involved in that, both cathode and anode, only carbon-based material. So we try to develop the material as well as fabricate the device, and then we also demonstrate whatever the cell which we fabricated in our lab for the on-field trials also. So here, like lithium ion battery, here also cathode, anode, electrolyte, separator, everything is the same template. But here both cathode and then anode purely carbon-based electrode. What happens during that charge, whatever the electrolyte, it gets absorbed on the cathode and then anode surface. If you have more surface area, you have that more energy storage site. And unlike lithium ion battery, there is no chemical reaction involved in that. That is the reason you can do the fast charging here, and then cycle life it will come nearly 1,000,000 cycle it will come. And then so there is no toxicity because you are using only carbon. Considering the advantage of fast charging, in China already they have introduced supercapacitor bus. So in a city, they are setting up that charging station at a different bus stop. The bus, it can go only 10 to 15 kilometers. When it reaches another bus stop, completely discharged. By the time passenger get in, get out, it get charges, and then it can go another bus stop. Like that. The thing is here, the power charging is advantage, and then 10 years life cycle without any degradation and all it comes. That is the advantage of supercapacitors. Like Switzerland, China, Poland, already they have introduced supercapacitor powered this one. And ARCI mainly focus on the material development for supercapacitor application. We are trying to use different bio as well as industrial waste, trying to convert this waste into supercapacitor grade carbon material, and then trying to establish the pilot plant facility for making supercapacitor from this material, and fabrication of cells using our indigenous carbon and demonstration. These 3 major we have taken for this supercapacitor program. And all you might be knowing that the jute plant. So we can extract jute fiber, which is commercial, all that jute bag and all we are using. After extraction of jute fiber, all this jute stick we are dumping as a solid waste. So as per the statistics, extracting every ton of jute fiber, we are dumping 2.5 tons of jute stick, and 4 million tons of jute stick we are dumping as a solid waste per annum in India. We are trying to use this solid waste and then try to give some value addition for this the solid waste. And we have used that the chemical activation process. Initially we make it into the fine powder, and then we do that chemical activation process, and then finally we do that all that washing and neutralizing with HCl. We fabricated this activated carbon. So you can see that here it is kind of few layer graphene like structure material we could be able to synthesize from this jute stick, and which is confirmed through this Raman analysis. Normally this D and G band corresponds to that amorphous as well as graphite carbon, whereas the band at 2700 centimeter inverse corresponds to the few layer graphene like structured carbon, and we could be able to see confirm that our material having that few layer graphene like structure. When you have that graphene like structure carbon, the conductivity always it is very high. And then this material we have done that the validation for supercapacitor application. Unlike lithium ion battery, you don't get that cathodic anodic peak. It is typical rectangular cyclic voltammetry we will get. And then here we have done that the validation. This is the typical charge discharge profile of any supercapacitor material. It will show that triangular behavior. This is that how many farad it can deliver per gram. Our material could be able to deliver 132 farad per gram, whereas the commercial material it can deliver 91 farad per gram, and more than 10,000 cycle it can retain more than 80% of retention. That is the advantage of supercapacitor, whereas lithium ion battery hardly it will come few thousand cycles. So this work also we have filed a patent and we have published the paper. So even though the material property, performance, everything is good, but the yield is only 35%. When you start with 1 kg, you will end up with only 350 gram of carbon. What we have done is, we have tie up with the oil company called HPCL, and we have joint project. And then you know that petcoke, during their refining process, they are generating huge waste of petroleum coke. It is in the tons level. They are generating. We used that petroleum coke as a raw material. Using our process, we convert into the porous carbon material. The advantage of using petcoke is it is abundant and it is cheaper. So per ton cost is only $100, and the advantage here is 90 to 95% of carbon it is there in that even in the raw material itself. And then when you are converting this porous carbon, we could be able to achieve the yield of 70%. The previous case we got only 35%, but here we could be able to get 75% of yield. And if you can see all the characterization properties, so the surface area is about 1500 meter square per gram. Here also we are getting that few layer graphene like structured carbon in the petcoke derived carbon as well. And when you see the performance, again the performance of our petcoke derived carbon is 128 farad per gram. Compared to the commercial one, it deliver only 98 farad per gram. So with this we have developed that material, and we have scale up to 220 gram per batch, and that material also it deliver 116 farad per gram. With this material we have coated in that longer length electrode, and this is the facility we have set up for making supercapacitor using our indigenously derived the porous carbon material. Nearly 11 equipment involved in that. This is the overview of our supercapacitor fabrication line. So you have to make the cathode and then anode. In between your separator it comes, and then you will be preparing that jelly roll. This is called the jelly roll. In both sides you can see that it is the previous one. You can see that this is the coated electrode, that in the end you can see that uncoated aluminum foil, which we are using for making the terminal, positive and the negative terminal. You can see that in both sides you have the uncoated aluminum foil, and this is the technique called flattening. So what we are doing is, first we are making that, so we are cutting, and then followed by we are doing the flattening. This portion we are converted into like this. It is kind of flattening we have done it. In both sides we have done that flattening of aluminum foil, and then this is that the flattened jelly roll, and then we have to take the terminal. Any battery we have to take the positive and the negative terminal, and then both side guided plate we keep and then do that the laser welding. Finally on top of this we keep that the lid. This laser welder lid, it will go into that aluminum can. This is the final supercapacitor device. So the interesting technique what we have adopted is, usually lithium ion battery they use that tap for taking the terminal and all. Here we have not used any tap. It is kind of tapless technique we have adopted to take the terminal from that devices. This many supercapacitor we have fabricated from our the pilot plant facility. Again here, again the benchmark. So we have compared our material performance with the commercially available supercapacitor with the same size as well as the capacitance. So we have done that the cyclic voltammetry as well as charge discharging, that the experiment we have done. And here you can see that the capacitance of commercial Maxwell, it is 1165, whereas ours is 1198 farad. And then the weight also ours is less compared to the commercial one. The energy stored also much higher than the commercial one. Only the volumetric energy density is slightly less because the height of our cell is slightly higher than that commercial Maxwell. And we could successfully fabricate supercapacitor device using our own material, which shows that performance at par with the commercial one. So we have successfully fabricated device, and then this device we assembled into a model. So nearly 15 supercapacitor we connected in series to get that voltage of 43. The energy is about 19.2 watt-hour. And then you need that kind of capacitor management system to control the voltage and then current during charge and discharge. We don't have expertise, but we collaborate with the Device Electronics Pune based company, and we made this system, and then we put it into the bicycle, and then we have run the bicycle for the driving of 1 kilometer, and then charging it will take only 2 minutes. It is kind of proof of concept. So how our supercapacitor demonstrated for that real application and all. This is what all that demonstration activities we have done it. And our main goal is supercapacitor we want to integrate it into the lead acid battery. So this is the literature, as it is only when you are using lead acid battery. In Varanasi and all you can see that lead acid battery auto. So lead acid battery, it cannot deliver the high power. Whenever you go for any ramping or speed breaker to cross the speed breaker, you need high power. But lead acid battery, it is not meant for high power. So when you are frequently using high power, the life cycle it will come down. What they have done, so this is only when you are using lead acid battery, the voltage, when you go for that the ramping and all, the voltage suddenly drops. When you are integrating with the supercapacitor, you can see the stable voltage profile. So this is the concept we want to adopt in our the e-rickshaw, which is running with the lead acid battery. Now currently this is that e-rickshaw which is run by lead acid battery. We integrated with that commercial Maxwell module. We purchased the model, supercapacitor model from that Maxwell company, and now we are trying to take out the data, how it the performance of lead acid battery when you are combined with that supercapacitor and all. So initially we are using commercial, and then later we are going to use our indigenous supercapacitor model into the lead acid battery. The advantage here is we try to increase the lifetime of lead acid battery at least for 2 to 3 years. So now every year you have to replace the lead acid battery. As of now, when you are integrating supercapacitor into lead acid battery, you can increase the lifetime to 2 to 3 years. So this is all that our supercapacitor invention was highlighted in the social media. These are all the detail. And anyway, this part I will skip considering time concern. So this is the conclusion of my presentation. So lithium ion battery technology is essential to reduce the carbon footprint and global warming. Large-scale synthesis of cathode and then anode material by pilot plant facility has been successfully accomplished and demonstrated in device level. So ARCA developed material exhibit electrochemical performance on par with the commercial material. We successfully fabricated supercapacitor device with a high capacitance for the first time in India using ARCA developed porous carbon and demonstrated for EV application. So I would like to thank my director, Dr. T.N. Rao, who is heading this lithium ion battery and then supercapacitor division. So, and also I thank Dr. Gopalan, so who is heading division in Chennai, for his support for the fabrication of cell using our ARCA material. And also I thankful to our former director, he is no more, and our Dr. G. Sundararajan, who established all the pilot plant facility in ARCA Hyderabad. And also I thank all my colleagues, and this is our whole team who is working in that actual field for the production of material as well as cell fabrication. This slide I would like to give some information about that students, the opportunity which is available at ARCA. The students who are all doing that final year BTech or MTech, so they can come and do their project work at ARCA starting from 3 months to 1 year they can do. Who are graduated, BTech, MTech graduated student, we are giving that 1 year fellowship. So they can work for 1 year and involve in all that ongoing sponsor project with the stipend. And also we used to give advertisement for JRF and SRF and with good stipend and all. And depends on that major project, we also give advertisement for scientist level with different junior, middle and senior level also. That also it come up. And then if you want the further detail, you can refer our website www.arca.res.in, and then that the HRD you can send a mail directly also. Thank you all for your kind attention. You can run that video. So I'll be running one short videos. So about that ARCA, about the technology which we have developed at ARCA related to lithium ion battery. The first one you please. This is about ARCA.
Welcome to an ever-evolving research and development center that has been consistently intensifying efforts in translating research to technology. ARCI, International Advanced Research Center for Powder Metallurgy and New Materials. An innovative center that has been working to quench India's thirst for high-performance materials and processes for niche markets since 1996. ARCI, an autonomous R&D center of the Department of Science and Technology, DST, Government of India. ARCI is primarily focused on developing nationally unique technologies through its application-oriented research and transferring them to Indian industry for commercialization. ARCI has been continuously evolving the formats by which it may engage with stakeholders from other R&D labs, academic institutions, and industrial organizations to develop technologies and innovative solutions suited for the changing world. ARCI presently has 11 centers of excellence. Its COEs have consistently worked towards development of new materials and processes, providing solutions to industrial users and transfer of technology for commercialization, including the PEM fuel cell system for stationary and mobile applications, oxide dispersion strengthened ODSTs for high temperature applications, nano-composite functional coatings for efficient solar thermal systems, joining technologies for automotive lightweighting, coating technologies for power plants, ultra-fast laser microprocessing to create features in the sub-micron sizes, high-performance ceramic components for applications ranging from energy-efficient air heaters to SiC-based substrates for optical applications. True to its mantra, translating research to technology, ARCI has successfully transferred 16 technologies to 28 receivers and more than 150 technological applications for industrial and strategic use. Detonation spray coating technology in late 1990s for aerospace, textile and hydropower sectors, which is still continuing to evolve with advanced features.
My experience is very unique with that organization. Started my unit in 2000 year in their ARCI's incubator center. Though I started with detonation spray coating technology, subsequently I entered into agreement with them for about 4 technologies like micro-arc oxidation, electrospark coating, and recently we have signed an agreement for laser cladding technology, which is a new development in Indian market.
Anti-mine boots for security personnel. Nanomaterials for textiles finishes with antibacterial and self-cleaning ability when exposed to sunlight.
ARCI is a friendly, collaborative and a competent materials partner. ARCI helped us to take this idea from mine to market. Silver technology was indigenously developed and patented worldwide. This helped in improving social wellness and hygiene. We received 2 national awards, one from TDB, another one from Nano India. We thank and appreciate ARCI for their contribution for this global project.
Silica aerogels based flexible sheets with outstanding properties for industrial thermal insulation. Apart from these, ARCI continues to strengthen its patent portfolio with filing of more than 100 national and international patent applications. ARCI serves as a springboard for inculcating interest in the young minds to opt for research as their career. There are innovative approaches afoot in the areas of materials for energy and environment through cost-effective solar cells, storage batteries, and supercapacitors for electric vehicles, low-cost fuel cells, magnetic materials, thermoelectric devices to recover waste energy from exhaust, nano-composite coatings to replace chrome-based coatings, advanced manufacturing processes such as additive manufacturing, laser micromachining, high-energy milling, high-performance ceramics, new steels for use in fusion reactor and supercritical thermal power plants, and improved machining tools.
RCA20 is now very enthusiastically poised. We would like to elevate the research enterprise at ARCI by further intensifying our interactions with the industries and user organizations, other R&D institutions, and together synergistically convert our knowledge into technology which is commercializable and usable. We have also resolved to align ourselves with the national missions like Make in India. The strengths and capabilities that we have built over the years, we are sure and confident that we will be able to aptly respond to any materials technology related needs of the country and the industry, and that is a promise from Team ARCI.
In essence, ARCI is evolving and innovating continuously to contribute to the field of application of materials and manufacturing technologies in general.
Hyderabad-based ARCI, an autonomous institute under the Department of Science and Technology, is continuously working on different materials to develop high-quality lithium-ion batteries and to reduce the dependency on imported products. To realize this goal, the researchers of the institute have now developed an indigenous technology to synthesize a lithium titanium oxide anode for fast-charging lithium-ion batteries used in electric vehicles. Take a look.
Fast-charging lithium-ion batteries are in high demand for portable electronic devices and electric vehicles. However, import of lithium titanium oxide and anode material for high-power LIB application makes the batteries costly. Plus, the complicated process of synthesizing this chemical makes things more difficult. Now, researchers working at the Center for Nanomaterials of ARCI Hyderabad, an autonomous institute under the Department of Science and Technology, have developed a simpler method to produce LTO, which can make the lithium-ion batteries less costly.
High material, the cost of the battery, which can be so importing material effective process of battery.
Lithium titanium oxide has emerged as a superior anode material for high-power lithium-ion batteries due to its thermal stability, excellent life cycle, and safety. Using titanium dioxide and lithium carbonate as precursors, ARCI team has developed a simple, economical, scalable, and energy-efficient technique for the production of LTO anode with improved electronic conductivity. LTO anodes exhibit recharge efficiency exceeding 98% compared to the other carbon-based anodes and have a life cycle of 20,000 cycles. These can endure temperatures ranging from -30 degrees to 55 degrees centigrade, making them highly suitable for difficult weather conditions in India. The high-energy milling method developed by ARCI makes them more economical.
ARC has imported a technology for production of lithium titanate, an anode material for fast charging lithium-ion battery for tropical Indian climate. The technology has been successfully developed at ARCI and validated at the device level. Further, the technology has been patented both in India and abroad. With this development, we are able to offer an indigenous, cost-effective technology for production of high-performance anode material for lithium-ion batteries, which also has long cyclic stability.
Although the use of electric transport is being promoted to save the environment from pollution, yet there is a dearth of economically viable electric vehicles. The cost of such vehicles increases with high power and high performance batteries. The zeal of ARCI scientists to develop indigenous technologies for high capacity, fast charging and long-lasting batteries will definitely make electric vehicles economical in the future.
Any questions and queries you want to ask?
That's a very good presentation, sir. Like I have few questions related to lithium ion batteries and then related to supercapacitor. So you have told of lithium ion battery carbon coated, right? One is a carbon coated and then other one is manganese, right? Okay. So lithium sulfur is not suitable for Indian environment. Lithium sulfurs are actually. Yeah, it is.
All it is in that R&D level.
Okay.
So, for example, if you see the lithium-ion battery, lithium ion, all it is the energy density about 250 watt-hour per kg. Lithium sulfur battery can go about more than 1,200 watt-hour per kg.
Okay.
There are a lot of the commercial issues are there. So there is one issue called polysulfide dissolution. So during that charging, discharging and all, that polysulfide formation takes place and then dissolve in that electrolyte. And then the stability issues, all it is coming up.
Yeah.
But a lot of research is keep going on to improve that, to minimize that polysulfide dissolution into that electrolyte. Once that problem is solved, then that also it will come into that commercial market, but it takes some time.
Okay. So what about this? Any other materials like along with the lithium ion, if you want to increase the energy density, is there any other material which is raw material which is available in India at least?
Sir, now alternative to lithium ion battery, so sodium ion battery it is coming up. Sodium ion battery again.
I am talking about only lithium ion along with any other composition.
Only that lithium sulfur is the next generation lithium ion battery. And another thing is aluminum ion. Aluminum ion battery is going to come up, and then magnesium ion. Whatever we are talking about lithium ion, it is monovalent ion, lithium plus. Whereas magnesium, aluminum, divalent, trivalent. So whenever you are going for that multivalent ion, where the energy storage capacity is high, but at the same time, because of that high valence state and all, your diffusion kinetics, it will be slower. So aluminum ion and all, it is keep coming up, but it takes time. In lithium ion battery, lithium sulfur battery is the next one.
And coming to supercapacitors, sir, you are developing some supercapacitors, right? Already commercially available supercapacitors are there. Maxwell and Nescap and Panasonic, they are developing, right?
Yeah, yes.
Supercapacitors. What way these are different, sir? The one we are developing in ARCA.
Yeah. So only thing is in the commercial supercapacitor device, they are using that coconut shell derived carbon. So even our India also, we have plenty of coconut shell, but the problem is our coconut shell is not suitable for making supercapacitor grade carbon, because our coconut shell having lot of inorganic minerals like sodium, potassium, those things and all, it is there. So during our high temperature process, all these minerals converted into respective oxides. These oxide, it create lot of resistance and all. So that's why our coconut shell is not suitable for making supercapacitor grade carbon. Whereas the coconut shell from Philippines, it is suitable for making supercapacitor. What we are trying to do, alternative to this coconut shell. Coconut shell, if you are using, you will get only 30% yield. Our intention is, we want to increase the yield. That's why we started using petcoke, where you can get that 70% yield, as well as you will not compromise in the property as well as the performance.
But power density will fall down, right? Carbon is having more power density.
More power density. That is the advantage of all the carbon.
But when you use this material, whatever material you are saying, then power density will fall down when compared to carbon. No, it will increase.
Actually, lithium ion battery power density will be.
No, I'm talking about supercapacitor.
Supercapacitor, all this material, we are not compromising the power density. Energy density, it will be lower, because the principle involved, it is non-Faradic reaction.
So power density is equal to.
Same. Power density always it will be higher for supercapacitor. We are not compromising the power.
Energy density will be little lower.
Yeah. Energy density, it will be obviously it will be lower.
Lower than the commercially available supercapacitors.
It is almost, when I showed that the benchmark, we are maintaining the same energy density. Commercial
also.
As well as our indigenous cell.
Only one answer I need, sir. Like commercially available supercapacitors are there, which is very well acclimated by the most of the industries.
Yes.
So what way the supercapacitor which is developed in ARCA is better than that?
So now, for example, when we are purchasing from abroad, you have to spend nearly 5,000 rupees.
Apart from that, sir, apart from the costing, apart from costing.
In the material property wise, we are getting the graphene-like structure carbon. And then when you have that graphene structure in your carbon, always your power density will be higher. And then whatever the coconut shell derived carbon, we are not compromising the performance. We are getting the same energy as well as power performance, as well as cyclic stability. So the property which we have generated from that waste to that the supercapacitor grade carbon, it is kind of value addition. The waste which they are generating in the oil refining process, million metric tons they are generating. We are through our process, we are giving kind of value addition to this one, because all the petcoke they are using in that aluminum cement industry as a fuel for road construction and all they are using. We are converting such a solid waste into the supercapacitor grade
carbon. So that means 2.7 volts supercapacitor, which is mostly that is the cost of the 2.7 volt supercapacitor. When compared to the Maxwell, the ARCA developed capacity is far lower cost than.
Yes.
That's great, sir. Then it's a great achievement for India, especially.
Low cost and the performance we are not compromising.
Thank you, sir. Thank you.
What is the effect of the cobalt material on lithium ion?
Cobalt, sir.
Cobalt, because it is having more higher energy density.
Yes.
So when we are going, why we are focusing more on lithium magnesium, lithium iron, as we have cobalt is the best in the combination.
Definitely, sir. When it comes to the energy density,
yes,
cobalt is the best one. Yes. So normally that nickel manganese cobalt oxide,
yes,
nickel cobalt aluminum oxide.
Yep.
These two cathode material used by the Tesla.
Yes.
Because they want that high range and all,
yes,
they want to use it. Yes. But the problem when you are running US, no issue, because the temperature it will not go up to that more than 30 degrees centigrade and all, material is okay. Yeah. But when it comes to that Indian climatic condition, the temperature it will not be 30. It goes above 50 and all during that summer.
Okay.
So even though I have driving range, if something happened, I cannot compromise my life for that shake-up driving range, right?
Yes.
First, my safety is important.
Okay.
For that, LiFePO4 is the suitable chemistry for that
Indian market.
Indian market.
Okay.
But you can use NMC, but the proper cooling system, you can use that
Yes.
NMC.
Yes.
You can use that cooling system for four-wheeler, but when it comes to two-wheeler, you have limited space available.
Yes.
If you want to keep additional cooling system, again, it is very challenging to keep that water cooling system.
Yes.
That is the reason two-wheeler LFP is the suitable chemistry. Okay. You can use NMC, cobalt-based chemistry also, yes, provided if you have the proper cooling system.
Okay. So one more question is, so right now, what is the role of micro batteries over lithium-ion batteries?
Micro batteries, most of the thing they are using in that medical applications.
Medical applications and the small gadgets.
So you have again that the medical grade batteries and all
yes,
there. The fabrication, everything entirely different from that whatever battery we are making for the electric vehicle.
Yes.
So completely, micro battery cost wise it is very expensive. You have that moisture, oxygen, everything you have to exactly follow that condition. And then something they are using for our operation and all, they are using some battery.
Yes.
And in place of that conventional battery, they are trying to use lithium ion micro battery and all.
Yes.
But here we don't have any technology, but US and all already established. But cost wise, it is very expensive.
Yeah, if we can develop the same lithium cobalt with graphene, is it a good bonding structure?
Graphene is a wonderful material, yes, which gives that all high electronic connectivity.
Yes.
Only issue is the cost as well as the density.
Density, yes.
Cost is it is high compared to the graphite.
Yeah.
And then the density wise it is very poor.
Yes, very.
The aerial loading when you are preparing electrode, it will be very less compared to that. For example, now we are making about 1 gram per cc.
Okay.
When you are using that the graphene, you may get only 0.3 or 0.4.
It is coming around 0.15, 0.12.
Because your is high surface area, highly porous material,
yes,
you cannot load. Yeah. In that case, your power density may be high, energy storage it will be less.
Yes. So if you come to graphene, what is the structure that the industry is, whether it is should be in the powder form or in the paste form, the graphene? Because converting a powder to paste, again, it is a complex process.
Again the coating process, lot of optimization.
Lot of things will be there. So generally, when we are developing Indianese model, whether we have to look into the powder type or into
the final electrode, we have to see,
yes,
what is the property we have to achieve. Accordingly, we have to tune all the property in terms of porosity, in terms of surface area, in terms of density. All you have to tune in the material itself according to get that final electrode.
Yes.
For example, electrode density, if you want that 1 gram per cc and all, here itself you have to use that high density material. Yeah. If I start with the graphene, I may not achieve that high electrode density. Yes. That may be, but wherever you need high power application, graphene based electrode it can be used.
Yes. So one last question.
Yeah.
Why the recent automobile industry is not using lithium ion battery in place of lead acid? If we take ordinary or petrol cars and everything, we have a battery which is a lead acid based battery. Why that lead acid based battery is not being replaced with lithium batteries?
Sir, again, lead acid battery cost wise it is cheaper.
It is cheap.
And then we have that very good ecosystem in India.
Yes.
Even buyback we will get that.
Yes, we will get some
one and then get that new one. Whatever the used battery. But the problem is now we don't have any cell manufacturing technology.
Yes, we don't have.
That is the reason the cost wise it is expensive than lead acid battery.
Yes.
Once that cost is coming down, then now already people started using that LFP based battery, which is combination with lithium titanate, which comes only 2.2 volt only, and the lead acid also 2 volt. Lead acid it will come only for 300 cycle. This it will come 5 times higher than that lead acid battery life cycle, but cost wise now it is expensive. Once the technology has been established in India, and then cost if it is coming cheaper, then lithium ion battery also it will replace lead acid battery.
Okay.
But it takes time because considering that our technology level in India.
So right now we are working on micro batteries with lithium cobalt.
It is a
structure.
very good area to work on that micro batteries. For all medical application and all, they need that.
So recently we are working on that.
Very nice.
And we have a SEM and everything.
Good, sir.
Yeah,
Good.
thank you, sir.
Thank you.
Thank you, sir, for your wonderful talk.
One question. Recently, zinc air batteries also been developed by IIT Madras researchers. Zinc air batteries.
Zinc air battery. All it has come up, sir. That's what I was talking about. All lithium ion and all it is monovalent. Zinc, magnesium, all it is divalent. Accordingly, your capacity it will be high, energy density it will be high. But the problem is when you have that divalent, trivalent and all, your diffusion kinetics it will be slower down, but the driving range, high energy and all, you will get it. All that the commercial challenges and all it is there, sir.
It is there.
For high energy application you can use zinc air battery. But this one, high power application and all, because the kinetics it will be slower when you go for that high oxidation state ions.
Yes, even in our India it is abundant zinc.
Yes, yes, sir.
So that is also some
yes,
aspects.
Yes, sir.
Weight aspect.
Yes, sir. It will be heavy. Yeah. Yes.
Yes. Another thing, ultra capacitors.
Yes,
supercapacitor, same.
It is almost same, sir.
Capacity wise.
Yeah, it is ultra capacitor means that fast charging based on that they are saying that ultra capacitors.
Yes.
It starts from that microfarad to what we have fabricated 1200. Maximum it is available is 3000 farad.
Okay.
It is available and it can deliver that 200 ampere current in a few seconds.
Okay.
And then fast charging. These are all the advantage, but only disadvantage, energy storage very poor.
Yes.
Because
and also one aspect is impulse, because it is a high fast charging and discharging.
Discharging, yes.
So flammability, that
yes.
also we have to see.
Yes.
Thank you for wonderful
presentation.
Thank you.
Thank you, sir, for your wonderful talk focusing on the topics energy resources and global energy consumption, also about operating principles, mechanism, applications of lithium ion battery, advantages of electrical vehicles, battery related challenges and many more. Also focused how students gets benefited under various schemes through ARCI. Now I request our beloved sir Dr. T. Suresh Kumar to give the memento as a token of appreciation from GRIET.
Ravindra sir, please come. Yeah, please come. Thank you, sir. Thank you.
That wraps up the session. Thank you all for coming. Let's leave for the lunch. Thank you.
For the lunch at 4410.
have all facilities?
Right now, not that complete nano-based facility.
Okay.
We have a limited facility. With that, we are trying out.
You can come, sir. Our solar center also they are doing great.
Okay.
So photovoltaic as well as solar panels.